Welcome to How to Make an App for Beginners. Now, it doesn't matter if you've never coded before. By the end of this video, you will have built this app. Now, I know it looks simple, but it's so powerful because you will have proven to yourself that you can make an app. And oftentimes, that singular belief is all it takes for you to continue growing your skills, building bigger and better apps, and potentially even starting a career in app development. Now, maybe you've been doubting yourself, or maybe you've been wanting to build that app in your head for the longest time, or maybe you've even tried coding and failed. We're going to turn that all around. My singular purpose for this lesson is to help you believe that you can build an app. And I think that once you realize that it's not as hard as people make it out to be, you'll be excited to continue to grow your skills and build bigger and better apps. So I really hope that you watch till the end and you see what happens. Quick note, in case there's any doubt in your mind why I am the right person to teach you this stuff, my name is Chris and I've been teaching App Development Foundation since 2013. Code with Chris is also the largest iOS channel on YouTube, and the last time we did this training series, it was viewed by over 5.4 million people. This lesson series that you're about to watch has even been used inside school classrooms and Apple retail stores. Now, all of that is just to say that you're in good hands. I'm so excited you're here. Let's roll up our sleeves and get started. I'm going to walk through this diagram, and then after I'll tell you where to get all of the pieces. It all starts with the Xcode IDE. Now, IDE stands for Integrated Development Environment, which is a term for the application and all of the tools a developer uses to build something. For the rest of this course, we'll simply call it Xcode. This is where we build our app by writing Swift code, building the user interface, or UI for short, and connecting it with all of our data. Swift is the programming language we use to express our logic and to tell the system what we want to do. We can even build the UI through Swift code, as you'll soon see. Now, SwiftUI is a UI framework that makes it easy for us to rapidly build apps for all of Apple's platforms. A nice benefit of learning Xcode, Swift, and SwiftUI is that they're the same skills and tools used to build all apps for all of Apple's platforms, including iOS, iPadOS, tvOS, watchOS, and macOS. And in some cases, your app will be able to work on multiple platforms without much changes at all. Now, once your app is built, you could distribute it with Apple's App Store. This is done by joining the Apple Developer Program, which requires an annual enrollment fee. Once you're enrolled, you get access to multiple benefits, including the App Store Connect portal, Test Flight, and the Provisioning portal. There are some more benefits, including access to beta software and support from Apple engineers, and I'll provide a link to the full list below. The Provisioning portal gives you access to tools for identifying and code signing your app. It's like putting your signature on the app so that Apple can identify who built it. And this is important for the safety of the end users downloading your app, and it's also important for you because it stops malicious coders from pretending to be you. Once your app is in a testable state, Test Flight allows you to invite people to download and beta test your app. They'll be able to send feedback and bug reports directly to you through the Test Flight program. Use Test Flight to ensure that your app is as polished as it can be before launch. And finally, App Store Connect is where you'll create the app listing for your app, including all of the metadata and screenshots. If your app has in-app purchases, this is also where you would configure them. Once your app is tested and the listing is ready, you can upload the app from Xcode to App Store Connect. From there, the certification team at Apple will review your app to ensure that it meets the App Store quality guidelines. This takes a couple of days, and don't worry if you fail because you can fix whatever they point out and resubmit it for review. If everything looks good, they'll approve the app and your app will be live. Congratulations! Alright, so where can you get these different pieces of the Apple developer ecosystem? You can download Xcode for free from the Mac App Store. I'll provide a link below. You don't need to get Swift or SwiftUI. Those just come with Xcode. As for the Apple Developer Program, I'll provide a link to the enrollment page below. I want to mention that joining the Apple Developer Program is completely optional. If your goal isn't to distribute apps into the App Store, don't join it. You'll still be able to learn how to build apps for yourself. Now that you have a general idea of the app ecosystem, let's start by downloading Xcode, and I'll show you how easy it is to use it to build an app. There are a couple of ways to download Xcode. If you already have it installed, you can go ahead and skip this section. However, if you don't, the easiest way to do this is to hold Command, press spacebar to launch Spotlight on your computer, and type in App Store. and let's open the Mac App Store on your computer and search for Xcode. And then you're going to click on the listing and then download it like that. A couple of things to note here though. Don't be turned off by the ratings. This is the official tool issued by Apple for us to build apps with. Also take note of the large file size. In my experience, it does take more free hard drive space than this in order to have it install successfully. And during the installation process, there may be times where you don't think it's doing anything. It seems stuck. It's going to take a while. Now, if for whatever reason you can't download it from the Mac App Store, you can also Google Apple Xcode and click on the listing here, and you can download it from the website. This will just lead you back to where we just were on the Mac App Store. However, if you download it from the website, do note that you have to sign up for a free Apple developer account or to sign in with an existing one. Okay, so once you have Xcode downloaded and installed, let's launch it and let's start a new project. This is going to be the welcome dialog for Xcode, and we're going to start a new Xcode project by clicking here. You can also go, if you don't see this, you can go File, New, and you can choose Project, same thing. Both will bring you to a screen like this where you can choose what sort of project template you want to start with. So we're working with iOS. Make sure you're on this tab and then go ahead and click App. And for here, I'm going to gloss over some of these project details because our goal is for you to get that result and make that discovery that you can build an app. So I am going to save all the explanations for lesson 2. Right now, I would recommend that you just follow along exactly what I do and get that result and have that app in your hand. All right, so let's go ahead and call this L1 demo. I think you probably have nothing for under the team. Organization identifier, you can put in com dot and then your name, no spaces. And interface, make sure this says SwiftUI. It should be like that by default anyways, and language should be Swift. Now uncheck all of those if they are checked. Go ahead, click next and choose a place to save it. Source control, this should be unchecked. I'm just going to save it on my desktop for now, since this is a temporary project. Now you're going to give it some time. It's going to boot up your new app project. I'm going to open this window up a little bit. You see how fast I was able to see something here on the right hand side for you. If it's a first launch, it will take a little bit longer, give it a couple of minutes even. But while that is going, we are actually going to go ahead on this left hand side here and click Assets. Now this is the asset library. This is where you're going to store all of the image and color assets for your app project. I've prepared an image file that we're going to use for this demo. You can go ahead and pause the video and grab any image you want. Save it somewhere where you know where it is. And what you're going to do is click and drag it into this panel right here, or this panel, doesn't really matter. This is a big panel, so let's drag it there. What you're going to see is this image asset that you've added to your Xcode project. Now take note of this name here because we're going to be referring to that image with that name. You can rename it by tapping and clicking it like that and just typing in whatever you want, or you can hit enter and you can also rename it like that. So mine's gonna be named Niagara Falls. That's perfectly fine for me. So now that you've got that done, let's go ahead and click on Content View. So by this time you should be seeing something on here, and what you see here is a preview of your user interface. So you can see what this screen looks like. And this screen right here on the right hand side is defined by the code that is written on the left hand side. I'm going to make this really easy for you to understand. We are going to delete all of this user interface and we're going to build it from scratch. And you'll see how easy this is. Right now it looks like a whole bunch of code that it's really hard to understand. We're going to change that. So let's highlight this code starting at VStack and then going all the way to the end of this line 18 padding. And I'm just going to highlight it all and just hit delete. And then I'm going to press enter twice so I can make some space in here. Now Xcode is going to throw a whole bunch of errors because it can't detect anything to display, but we are just about to add some new elements on there. So in the upper right hand corner, you see this plus icon. If you put your mouse over it, it's going to say library. So we're going to tap on that, and then by default it should be on this first tab actually. So I was using it before, so it was on the second tab, but I want you to go ahead and click on this first tab. This one is all of the views that you can add to your screen, and I want you to in here type in image, and you're going to click on the second one called image, and you're just going to drag and drop it right where all of that code was that we just deleted. So this is an image view. It's going to allow you to display an image. You're going to click this middle part, you're going to hit enter, and you're going to change the text inside the quotes. So I'm going to get rid of that. Notice that I still have the 2 quotes here. In between those 2 quotes, we're going to type in the asset name. So just to remind ourselves, let's go back to the asset library. Mine is called Niagara Falls, like that. You're going to type in exactly verbatim what you have here, including any spaces, dashes, capital letters, anything. You're going to type it exactly in between here. Because if it doesn't match, it's not going to display. And you can also, at this point, rename it to something that's easier to type if you want. You can do that. And what you're going to see is the image. This is previewing what we have here. Now this doesn't look quite right to me, so I am going to modify this image view. I'm going to customize it. We're going to open up the library again by tapping that, and this time we are going to switch over to the second tab. And these are where all the modifiers are. So modifiers are things that we add to the view to change its properties and attributes. First of all, let's add something called resizable. So you only have to type in the first couple of letters and you'll find this. So this allows you to, it tells the system that this image can be resized. So I'm going to click and drag once again and put it, you can either put it at the end or you can put it right underneath. And right away, give it a little bit of time, you'll notice that it changes. The other thing you'll notice though is that the image now looks a little bit squished, right? It looks squished and the aspect ratio is not correct. We're gonna also add a modifier to change that. But first, I wanna round the corners. That's something nice and easy and it looks pleasant. So let's go ahead and do that. Let's add another modifier by opening up the library. We are going to this time, make sure you're on the second tab, modifiers, and search for corner radius. Click drag and drop again. And this is the nice thing. We're going to put it underneath resizable. You see that it's automatically going to put a space for you. Make sure you don't accidentally put it down here or like after this bracket or anything like that. You want to put it after the resizable so that it's going to look neat and tidy like that. And you're going to notice a slight corner rounding, but we can't really see it, right? So we are going to change this number. Let's change it to 10 and see if we see anything. I can see slightly more rounding now, but take a look at this as well. I'm going to leave my mouse anywhere on image, resizable, or corner radius, my cursor I mean, and on the rightmost side here, you can see a whole bunch of things you can configure. After we added that corner radius modifier, you see right here, this reflects what we typed in right here. And in fact, if I press plus, you can see it's changing the number. Right, so this is a very easy way for us to modify the code visually through an interface here. Okay, so I promised that we would unsquish this image, right? Let's go ahead and open up the library and we are going to search for aspect ratio. And we're going to drag and drop this one right under corner radius. So again, make sure you put it right there. And if you accidentally put it right here, for example, you can go ahead and delete it and try it again. Now I'm going to put my cursor on aspect ratio because I want to change the type of aspect ratio. We can define how we want this to behave. Let's make a little more space. You can drag this and make the preview a little smaller so the code will fit on one line. So you can see here it says fill, which is exactly what we have here. I'm going to pull down this drop down. I want to find one that's called fit because that will actually shrink the image down, keeping the aspect ratio until it fits the screen, which is what the behavior that I want to see. Unfortunately, it's not in this drop down. Maybe Xcode can't detect it. However, don't forget, we can modify it through the code as well. So I am going to get rid of this fill by just, I'm going to delete it like that. And then I'm going to hit dot on my keyboard and out pops this menu. This is called the autocomplete menu. And it's going to allow you to select from different options without having to type too much. So just by hitting dot, it opens up this menu and it gives me different options. Now there we have fit, right? An option that resizes the content so that it's all within the available space, both vertically and horizontally. Let's choose that and see how that looks. Perfect, that's what I wanted. Now, one thing to note, if you press dot and that menu doesn't pop up, that's perfectly fine. Just type this out, .fit, and you're gonna get the same result. Next, I don't really like how it's touching the edges, so let's go ahead and add another modifier. This time it's called padding. So we're gonna drag and drop that. So you can see how easy this is, right? You don't even have to write all of this code. You can do this visually. I like the way the picture looks now. Let's put a piece of text underneath. So we're gonna open up the library again. And you see a common theme here. This time we're gonna switch over back to the Views tab, and we're gonna search for text. I'm gonna drag and drop that. This displays a piece of text, right? And you wanna make sure that you never, you wanna respect the brackets, right? So you never wanna put anything outside of these two brackets, because you see when I click it, right? When I click this, it shows the opening bracket. We have to put all of the components after this opening bracket and before this closing bracket. So think of it as a sandwich. So there's my text. Let's go ahead and double click placeholder. And once again, I can get rid of that text in between the quotes, and I can type in whatever I want. But you might get some errors in Xcode now, or worse yet, Xcode might not tell you what's wrong, and it might just not show you anything, as in what's happening right now. So the problem is that it doesn't know how to lay out these two elements. How do you want them arranged? On top of each other, beside each other? It doesn't know. Luckily, we have something called a layout container to tell the system how to lay out multiple elements on the screen. So again, let's open up the library under Views. Let's search for vertical stack. You can type in VStack or vertical stack. We're going to choose this one, not the lazy ones. So vertical stack, let's drag and drop that. I'm going to put this above the image this time. You'll see that this one, let's add some space in between it. This one comes with an opening bracket and a closing bracket, and in between it says content. So what a VStack does is whatever content is in between the opening bracket and closing bracket, it will lay it out on top of each other. So what we want to do is we're going to delete that content, and we are going to move this image along with all of its modifiers, as well as the text element inside the VStack, right in between these two brackets. So I'm going to press Command X to cut that code and put my cursor in between those two brackets and press Command V to paste it. And what you're going to see on the right hand side is now it knows how you want to arrange those elements. I want to change the text. Let's go ahead and add some modifiers, right? Okay, let's open up the library, change to the modifiers tab, and we're going to choose one called font. And you might not see it right away because, I mean, the search, I guess the word font is in the descriptions of all of this, but we're specifically going to look for one called font. There we go. Let's put that at the end. And then I'm going to hit enter to just organize it a little bit. And with this font one, you can change already. This is a title font, so you can see that it made it bigger. On the right hand side, if you put your cursor on the text, you can see the font here. It refers to title. I can go ahead and choose that and choose large title, for example. It makes it a little bigger. And let's say I wanted it to be bold. Let's change the weight to semi-bold. You see when I did that, it added a font weight modifier and set it to semi-bold. So I could have done this another way. I could have actually, I could delete that, and then we could have gone via our trusty library method, and I could add the font weight modifier like that and change this to semi-bold. So we would get the same result. Okay, now let's put the finishing touches on this app. So what I want to do is add a black background, and then we're done essentially. Okay, so how do we add a background here? So this is kind of not intuitive, but you're going to get used to it. Is if you want to add a colored background, you add a color element to the screen. So let's open up our library. It's under Views, and we're going to search for color, and that's the one right there. So we are going to drag and drop it. Once again, I'm going to put it above the V stack like that. And you can see, you can specify different percentages of green and blue. So if I wanted a black background, this would be like, they would be all zeros, and that would be black. However, there's also a different way to specify black. I can get rid of all of that. Like, this is good if you want a really custom color, but there are some presets that you can use as well. So I'm going to put color, I'm going to leave the 2 brackets like that. And in between those 2 brackets, I'm going to put dot. It's going to open this up. If it doesn't open for you, that's fine. Just type out dot black, but I'm going to choose it from here. And that's preset. Now notice how this color, first of all, it covers everything. Second of all, it doesn't reach the edges. Okay. And the reason why it doesn't reach the edges is because this is what's known as the safe area. This is where things like the battery percentage and like the time displays. And down here, you have that little handle that you can grab and you can, change between apps or minimize an app. So if you want your elements or your colors or whatever it may be to go into those zones, the safe area, you have to add a modifier to tell it to do so. So let's go ahead and add that modifier. Hit open the library and then switch the modifiers, and let's type in ignore. And there's this one, ignores safe area. So you're basically saying that you don't care about the safe area and you want this element to go into that danger zone or that safe area. Now you can see our color covers everything. The problem is we don't see anything else. So why don't we try making some space in our V stack right here and highlighting our color with the modifier, Command X to cut it, put it in here, Command V to paste it. What do you know? Our V stack puts it, arranges it on top of each other, but it's probably not what we're expecting, right? And you can see that it did it in a way, it's pretty smart, where it gave each element enough space. So this is as much space that like the text needs, and then the image, and then the black color takes up the rest, whatever else is available. But that's not really what we're after. We want the image and the text to sit on top of the color element, right? So there's another layout container we can use. Let's check it out. Let's go to views. It's called a depth stack, or in other words, a Z stack or Z stack if you're Canadian like me. So this one is going to be special. Things can actually sit on top of each other on the Z axis in sort of like a depth. You can have, depth would be the best way to describe it, right? So let's try this out. Let's erase content and let's first of all move the color in there. Command X, Command V. And next we are going to add our entire V stack in there. Okay, so let me just remove some of the space. Make sure this is very, you got to be very careful because we're moving things around. If you misalign one of the brackets here, it won't be able to read your code properly and it won't know what sort of layout to make. So tap on this bracket and make sure that when you do this, that it's highlighting the bracket that you expect it to. So you want to grab the V stack along with its opening bracket, along with all the contents, along with the closing bracket. So I'm just highlight all of that, Command X, and in here inside the Z stack before the closing bracket, I'm gonna put that in there. So what it's gonna do is it's gonna put the color at the bottom, and then it's good to put the V stack along with all of its contents on top of that. And so we have this. Unfortunately, our text is not visible. So let's go ahead and add a modifier. So I could just do this and choose white, or we could add a modifier. And the one that we're looking for is foreground color. That's what we would add to change the color of the text. However, let's modify it here and see what happens. See, when I chose white, it added the foreground color modifier for us and set it to color white. Pretty simple stuff, right? Now comes the fun part. Let's launch our app. Now later in this video series, I'll definitely show you how to launch this app or any app on your phone or your device. For right now, we are going to run this in the iOS simulator. So up here, you're going to notice it says iPhone, whatever. Well, it depends what version of Xcode you have, but I want you to tap on that and you can choose a bunch of different simulators. Choose the latest iPhone that you want. I'm just going to choose iPhone 14 and I want you to hit this run button. Now give it a couple of minutes and then you're going to see a virtual iPhone on your screen. I have to warn you though, if this is the first time you're running the iOS simulator, it's going to take a few minutes to boot up, but subsequent times it's going to be a lot faster. Now here it is. This is the simulator. Now the cool thing about the simulator is that there are some quick buttons here where you can rotate it to a different orientation so you can see what it looks like. You can take a screenshot. You can even take a video from the menus up here. You can hit this to go back to the home screen. This is a virtual iPhone for you to test your app. Now, what is the difference between this simulator and the preview that we had inside Xcode? Well, this simulator is great for testing your app because it has features to, look, you can simulate a shake, you can test out Face ID, you can simulate locations like a custom location, you can simulate a driving car or a bicycle ride. So there are lots of things or tools for you to test your app, whereas the preview is good as exactly that, a preview while you are building your user interface. If you want to download this project, just check in the video description below. Now I hope this lesson has showed you that building apps is not some mystical dark art. Granted, this app was simple, but every lesson that you complete after this one, you're going to gain a new skill. Now, just in case you get stuck, we also have a free community where you can go and get help. Just visit codecrew.codewithchris.com. So between this lesson series and the community, I think you're going to make pretty good progress while having fun and learning a lot. I mean, these people did. Did you think I made those app icons up? In the next lesson, we are going to dive a little deeper into Xcode and I'll explain what the rest of the files in your app project do. In the last lesson, you used Xcode to build this. Now in this Xcode tutorial, I want to take a little more time and show you around so that you can understand what you did and begin to master this tool. Now you're going to want to pay close attention because over the course of your journey, you're going to be spending a lot of time inside Xcode, turning your app ideas into reality. Oh, and at the end of the video, I'll be sharing my Xcode tips and tricks with you that I use every day, so make sure you watch till the end. Okay, quick note before we begin. Back in lesson 1, I showed you how to download and install Xcode, so if you haven't done that yet, go ahead and do that first. Once you have Xcode launched, let's get into it. All right, let's create our new project. Click Create a New Xcode Project right here, or go to File, New, and Project. Now there are several options here, actually they're templates, and you can create apps for different platforms, macOS, watchOS, tvOS for cars, even multi-platform if you want to launch your app on multiple platforms. However, we are going to choose iOS app. And actually, look, there's game, AR apps, there's iMessage, sticker packs, ton of stuff. We're going to stick with the basics for now. This is a good starting place. Let's click next. And here, let me explain some of these options for you so they don't look so cryptic. First of all, product name is easy, right? We're just going to put whatever we want to name this app. Now, team is something that I want to explain. Remember back in lesson 1 when we talked about the process to launch your app into the store? Well, the code from Xcode that gets turned into a code package, and then you have to code sign it, as in put your digital signature on it so that people can't impersonate you. And then that's the thing that gets put into the App Store. Well, this here is how you're going to code sign it. And to get a team on the drop down here, you actually have to sign up for the Apple Developer Program, which is that yearly paid program to allow you to submit apps. It will give you access to a portal where you can upload your digital signature, and that's how you're going to be able to create a team in here. But for the purpose of these demos, we can leave it as none. Now, what's more important though is this bundle identifier, because this is the unique ID for your app, and this has to be unique for all apps on the App Store. It's a combination of your product name, as you can see, as well as your organization identifier. And here you can put anything. Typically, people do your company name or your personal name, and together that is your bundle identifier. Now, the next two pieces, interface and language, I want to draw your attention back to that diagram in lesson 1 where we said SwiftUI is how you're going to build your user interfaces. Swift is the coding language you're going to use to express your logic, and together you're going to use those two tools to build your app. And that's essentially what these two things are. There are some options, however, in particular for interface. If you pull this down, you can select Storyboard or SwiftUI. SwiftUI is definitely a lot easier to learn, and it is the UI framework moving forward because SwiftUI is sort of the replacement for storyboards. Right now, as of today, there are still companies out there using storyboards, but Apple's full intention is to discontinue that and move forward with SwiftUI. So I would definitely recommend learning SwiftUI. And if you do choose SwiftUI, you have to choose Swift. If you choose storyboard, you can still learn Objective-C. But again, I wouldn't start with Objective-C unless you had a very, very good reason specifically to do so. Maybe you are trying to target a job that only uses Objective-C, and that's what you would pick. But SwiftUI and Swift is where we want to be. Now these two options here, core data and include tests, these are options that you can always add to your app after the fact, so you don't feel pressured that you have to check them here. But even for the purposes of what we're learning, these are unnecessary. So core data is a way to have a local database on your device, and tests is used in software development where your project gets really big and you need to write automated test cases, because once your software gets really large, if you make a change, it's not feasible for you to manually test all the features all over again for every single change that you make. So you need to include automated testing that you can just click a button and run, and it'll say pass, fail, and you can see what breaks after you make a change. So again, not for us. Leave these unchecked. Let's go ahead and click next. And now you can choose a place to save it. I would recommend, if you are taking this seriously and you are going to continue on learning, create a space in your hard drive, a folder, perhaps for all of your apps and projects so that they can stay organized. For myself, I'll admit I'm a bit of a messy person and this is a demo. So I'm just gonna create it on my desktop. Source control. Now this, if you don't know what this is, it's kind of like versioning. So imagine being able to take snapshots of your project and code so that later on, if you accidentally break your project and it's not working anymore, you can always roll back to one of your snapshots. This is kind of like Time Machine on the Mac if you've ever used that. So definitely a very good practice in software development. In fact, kind of mandatory if you're working professionally. For us right now, we are going to leave this unchecked because I will introduce this to you later on. Okay, let's go ahead and create it, and let's check out our brand new project. So here's our brand new project. Before we dive into each of these files and tell you what they're for, let us talk about the major big areas of Xcode so you can get acquainted. So there are 5 main areas of Xcode. Firstly, on the left-hand side here, you have your navigator area. In the middle, the biggest area, you have your editor area. On the right-hand side, this is known as the inspectors or utility area. Across the top, at the top here, you have your toolbar area. And at the bottom, tucked away, is this debug area, which you really only need when you start working with code. So we're gonna hide that again. So those are the 5 major areas of Xcode. Let's dive into each one, and I'll show you in the context of your project what these areas are for. Let's start with the file navigator. So here you have your Xcode project and all of the files in your project. So you can see these are collapsible folders. These are the files. These are the asset libraries that you learned about in lesson 1. But notice across the top here, there are tabs to the navigators. This first tab is the file navigator or project navigator, but there are different types of navigator. So you will encounter these when we get farther along. Right now, there's not too much to see. I would leave it on this first tab under file navigator, project navigator, so you can take a look at all of your files. Next, let's move on to the editor area, the biggest area. This is where you're going to be spending most of your time editing your files. Notice that this area changes depending on what you're looking at. This file is a pure code file, so it's all code. This one is a view, so you're going to get half code, you're going to get the preview. And asset library, again, it changes. So the editor area is very versatile. It changes depending on what file you want to edit. Now, inside the editor area, there's also a lot of cool little tucked away things to make editing easier. such as across the top here, you can have tabs, there's a breadcrumb, you can even jump within the file, and you can open up, you can split up this editor area into multiple panes, window panes as well, which I'll show you closer to the end of this lesson. For now, let's move on to the rightmost side. This is the inspector area. Sometimes people call it the utility area, which will work as well. However, what this is for is it allows you to configure whatever you are working on or looking at inside the editor area. So for example, if we, you've seen this. If I put my cursor on one of the view elements here, I would be able to configure it, right? If I put my cursor on this thing called view, there's nothing I can configure with this keyword view. However, if I click across the tabs here, there is a quick help tab. Now this is useful because it tells me what this view keyword means and what it does. Here, this tab is the identity tab. It tells me where this file exists, where this content view exists on my hard drive, right? And what app membership does it belong to and things like that. So that's what the inspector area is good for. Now, I don't know if you've noticed, but there is a cascading effect going on, right? If I select this, it changes this. If I select something in the editor area, it changes what happens in the inspectors area. So think left to right waterfall. Next up, let's look at the top toolbar. Now, first of all, this leftmost button hides your navigators. If you need more space on your laptop, maybe your screen is kind of small, you can make more space. On the right-hand side, there's a similar button to hide the inspectors area. So now you get a full editor area for editing. There is this run button to run your app inside a simulator like we did in lesson 1. And here you can click on the simulator to select a different one. You can test your app on all sorts of different simulators. Also, if you plug in your device into your computer, you are going to see that device here, and you can choose it, and you can actually launch your app on that device. So that's something we're going to do in this video series. So don't worry about that. We'll get to that. There, when you first plug in your phone, you're going to get a pop-up on your phone saying, do you trust this computer? And you're going to have to say trust before you can actually see it on this menu, just in case you're doing it right now. Here, it tells you what's happening behind the scenes. Sometimes, if you're thinking Xcode is slow, it might be because it's doing something behind the scenes, and this is the status bar that tells you what's going on. Now, this Xcode Cloud is something that you don't have to worry about yet, but it's a way for you to be able to run your projects and test, run those test cases that I told you about when we created the project. It's a way to run those test cases on the cloud, on Apple's servers. The reason is because sometimes these take quite a while to run, and also you might want to run those tests on multiple different devices, and so you can deploy those things to the cloud and run them there. This icon we've used before, it's the library, right? So if we go back to the content view and you click this plus icon, there's our library. That's so useful. And then, we talked about this icon. So that's the toolbar. Now that you know your way around Xcode, let's take a look at your project files. So let's start at the very root of your Xcode project, which is inside your file navigator, this node right here. Now, this is where you can configure different things for your project. These are things like, what is the version number? What is the display name? Should it be able to display in various orientations? And all the things like that. Actually, this is probably pretty important. What iOS version should it be able to install on? You might set 16, and nothing lower than that will be able to install your app. And this is for the reason that sometimes you're using features which are only available on, let's say, iOS 16. So that is the root project node. Here is also where you would configure different things like you might have to add different capabilities to your app, such as Game Center or being able to do in-app purchases or notifications or things like that. You have to add different things. And just in general, there's a whole ton of settings. This is your project settings. Now, after that, there is a folder. Inside contains a couple more files. you've got this entry point. This is where your app starts. Okay, this is the first thing that gets executed before it launches the first screen of your app. And that is what this is, content view. If we click onto the next file, that is content view. You can see here, this is what it looks like. And the entry point, if you click back here, you can see that it creates a content view. So that makes sense, right? This is the entry point for your app. When the app launches, it creates this screen, content view, which is what you see here. And in fact, when you launch it in the simulator, this is the first screen that you see. So hopefully that makes a lot of sense. And next you have your asset library, which stores all of your colors, your image assets, and even this is where you'd specify your app icon. You just place an image into here to have that be your app icon. And then inside preview content is another asset library, but this is just only specifically for the previews here that you see. So if you perhaps, sometimes previewing doesn't make sense if there's no data to preview, right? Like for example, if you've got a scrollable list of photos, but you don't have any actual photos, there's nothing really to see, right? So this is where you would put those test or preview assets to be used. And that, in a nutshell, are all of your files in your Xcode project. Next up, let's see how we can test our app. Now, in terms of testing your app, we mentioned the simulator in lesson 1. So just as a recap, you can select a simulator of your choice here, and then you can hit this run button and it's going to launch an on-screen virtual device. If this is the first time you're doing it, expect a couple of minutes for this to boot up. But here, this is a great way to test your app. You can click through all the screens and interact with it. You can simulate different device features such as low memory situations or low network situations to see how your app would behave. And in general, just test your app. This preview here in the editor area is actually great for seeing how your screen looks like as you build it. And there are a couple of tools for that. For example, there are zooming capabilities here. You can zoom in, zoom out, zoom to fit, and zoom to 100%. That's what these different buttons do. You can also look at variations. For example, I can look at what dark mode would look like on my phone, or I could look at landscape orientation. If this is too tedious, you can look at multiple variations at once by clicking this button right here. And for example, I can click color scheme, and that's going to show me light and dark. I can click on orientation, for example, or maybe dynamic type, and see how different font sizes look on the UI. And then finally, we have these two different modes. By default, it's on this live mode, which lets you interact with the elements on your preview. For example, I may add a button. Let's open up the library under views, search for button, you'll see it there, and click and drag it and you'll see a button. You can see by default, I'm on live mode down here, and I can interact with this. There is another mode called selectable mode or select mode, and it allows you just simply to select your elements. Perhaps you want to see the corresponding code for that element. So that's a great way to learn. Another functionality is selecting an element so that you can configure it in the inspector area. That's pretty helpful as well. And now I want to leave you with some Xcode tips that I use every single day inside Xcode. These are so useful. And it may not be apparent right now, but as we start building the app in this video series, you're going to see us using these. So the first one, probably the most basic one, is this one here. These go back and go forward arrows. These work just like your web browser arrows. And sometimes, let's say you're moving from this file to another file here and there, these buttons just let you jump back to the place you were in. So when you're working with code, sometimes the code file gets really long, and this breadcrumb right here allows you to jump between different sections in your file, which is really handy. Here you can actually jump to different files as well, clicking this breadcrumb right here. On the upper right hand corner here, there are a few useful things as well. So this middle icon allows you to customize how the editor looks. So if you choose show editor only, you don't need the preview, perhaps. You can click that, right? You can also, there's this mini map, which is quite useful as well, which lets you scrub your file. So if your file was very, very long, this would be an easy way to just
sort of navigate and you can see at a glance what your file is looking like. If you want to, let's say, look at two files side by side, you could do that by clicking this upper right hand corner button and opening two editors side by side. And obviously, the more screen real estate that you have, the more useful this becomes. As for now, it is probably not very useful for me with the size of this Xcode window and with the size of the font that I have right here. But nonetheless, you know that this is available to you. And there are different tabs right here, as you can see here. Now, as you code more, you'll undoubtedly run into a situation where you're wondering, what else can the VStack do? Or can the VStack do this or that? So I'm happy to say that documentation is embedded right into Xcode. Now, you can just Google VStack and find it, or there are a couple of fast ways to do that within Xcode. So one way is go into Windows, Developer Documentation, and you can just search up VStack in here. I've already found it, but yeah, you can do that. You can look at what it can do, how to use it and things like that. An easier way, even faster, is just putting your cursor over it and using the inspector panel and going over to this quick help section. And then you can even click on the link here to open it to that page. Even faster, if you want to hold down the Option or Alt key on your keyboard, hover over VStack, and you can get a pop-up dialog for that. Again, there's a link to open the developer documentation. Really handy stuff.
All right, so now you know all about the file navigator, the editor area, the inspector area, the toolbar, and the debug area. And you know how to start your own Xcode project and what each of the files in your project is for. In the next lesson, we're gonna get hands-on again, and you're gonna learn even more skills for building user interfaces, aka the screens of our app. In this lesson, you're gonna learn multiple ways of how to build a screen of your app. Now, I know you're itching to build user interfaces like these. These were done by our designer JC in a piece of software called Figma. As you improve your skills, you'll be able to translate designs like these into your own app inside Xcode. By the end of the lesson, you'll have built this, using only these few basic elements. A few layout containers, a few views, and a few modifiers. Considering that we're only 3 lessons in, this is amazing progress. Okay, buckle up, let's get started. Oh, and just a quick note, in the last lesson, you learned how to use Xcode, so if you need a refresher, check it out right over there. Also, if you're enjoying the series so far, don't forget to give this video a thumbs up and subscribe so you don't miss the next lesson.
Let's quickly review how these building blocks come together to form the user interface, or UI for short. So views are the elements that the user sees on the screen. Modifiers are applied to the views to change its behavior or look and feel. Finally, layout containers organize and arrange views in various ways. Now, fun fact, layout containers are also considered as a view. Just think of them as container views. All right, let's start by creating our Xcode project. So go ahead and start a new project. Under iOS, let's choose App. I'm going to name mine L3 Demo 2 actually, because I've built this once before. Team you can leave as none. Organization identifier should be the same as before. And then make sure it says SwiftUI and Swift. Core data and tests are unchecked. Then let's go ahead and click on Next. And I'm going to save it on my desktop. You can leave Create Git repository unchecked as well. Okay, so here is our brand new project. Let's expand the window a little bit so we have some space. And the first thing we are going to do is just add the image asset for that card into our asset library. Now, again, just like last time, you can put whatever asset you want. I'm going to reuse the Niagara Falls image asset that I used back in the lesson 1 demo. So go ahead and do that. Okay, now, in order to build this card, I first need some idea of what I'm going to be building. Now, whether that's just in my imagination or maybe a rough sketch on a piece of paper, or perhaps it's a design by a designer. In this case, I had this in my head and I wanted to lay out the biggest elements first. And that would be the image and the 2 pieces of text. In addition to that, I also have in mind the basic layout container that I'm going to use first. In this case, that would be the vertical stack, which arranges the views on top of each other. So let's go into our content view first, which is sort of the default view that gets created for you. And I'm going to remove the VStack along with its padding modifier. So we should be left with body, opening bracket, ending bracket, and then this content view here, opening bracket, ending bracket. What we're going to type in, so at this point, actually, the way we've been doing it is by using the library. If you feel confident, you can just type out the code. If you don't feel that confident yet, you can go ahead, click this plus icon, open up the library, make sure you're on this views tab, and just type in image, and drag and drop it. That's perfectly fine. This is a perfectly safe way to build up to the point where you're comfortable just writing the code, and then sooner or later you won't even be using this library. For the image name, we are going to follow what we have in the asset library, whatever your asset is named right there. So remember to use the quotation marks, and we should see an image. Perfect. Now, obviously it's too big. I want it to fit on the screen. So we are going to add the resizable modifier. So what you do is press dot and the autocomplete menu will pop up, and I'm just going to choose resizable. Again, you can do that from the library, but make sure you go to the second tab, right, which is the list of modifiers. You're going to search for resizable. You're going to just drag it and drop it there. Another one we're going to add is aspect ratio, because this looks kind of squished, right? And this is all review right now from lesson 1. We've done this together before. It's going to be exactly the same way. So there's aspect ratio. I'm going to hit dot to open up autocomplete again and choose, I'm going to type in fit, or just choose it from the menu. Again, if you don't see it from the menu, you can just type dot fit and you'll still get the same result as what I'm seeing here. And hit enter. I'm going to do dot again. This time I'm going to add corner radius, and this is going to round the corners nicely. I'm going to put 15 as the amount of rounding that I want. And remember, in the inspector view here, you can choose this tab to configure the modifiers and the view itself. So you can see here, this is the image, this Niagara Falls. I can change the aspect ratio, change the color. I can add some padding. Here's the corner radius. I can increase it or decrease it. Because my cursor is right now, it's on image. If it's on body, I won't see that there. Okay, so that does it for the image. Now, I said that we would use the vertical stack to arrange it, right? So let's go ahead and do that. Again, I'm just gonna type it out, but feel free to use the image library. And the vertical stack, whatever is inside of this pair of brackets right here, those are the views that get arranged on top of each other. So we're going to have to move this image. I'm going to press Command X to cut it and put my cursor inside the brackets, press Command V to paste it in there. And then I'm going to add the text elements. So let's go ahead and type in text, quotation marks, Niagara Falls. Next, let's add the description. So I'm going to put another text element here, and you can type whatever you want. All right, that's speaking pretty highly of the falls. Now, what we're going to do is I want everything to be left aligned and also to add some spacing between these elements. So if I put my cursor on the VStack, we can come over here and into the inspector panel, and we can actually configure those things. So let's see how that changes the code so that next time we can just type in the code straight away without having to use the user interface. So we're going to click this alignment, and that adds this alignment parameter here and changes it to leading. Let's change the spacing. I'm going to put 20 in there. And you see that adds another parameter, spacing equals 20. And then in the preview, you can see those things have taken effect here. Now let's make the title a little bigger here, Niagara Falls. So I'm going to put my cursor on the text, and we're going to change the font to perhaps title font. And let's make it bold. Let's change the weight to bold. Next, I want to create the ratings to the right of the Niagara Falls title. Now, when I see things side by side, I think horizontal stack. This is the same as a vertical stack, but instead of arranging things on top of each other, the horizontal stack arranges things side by side. So let's go check it out. So back inside Xcode here, since this is the first time we're using it, let's go ahead and bring it out from the library so we can see the code. Let's go into the views tab right here and type horizontal stack. That's the one right here. and let's drag it right before the Niagara Falls text. As you can see, it looks exactly like the V stack, except it's an H stack. So we're going to move this Niagara Falls title into the brackets in between there. Command X to cut it, Command V to paste it. Now, visually nothing changes because I don't have anything aside from that text inside the H stack. But one thing I want you to notice right now is that we have an H stack inside of a V stack. So this is how you can begin to build a layout from a combination of layout containers to arrange the views as you want them. You can nest these layout containers. Now let's go ahead and add an image beside the Niagara Falls. We use the image element just like how we displayed the waterfalls, and we can search and find an image of 4 stars or 4.5 stars, whatever we want to display. Then we can add that to our asset library just like we've done here, and then we can put the image name here to display it. But I want to show you a different and arguably better way to do this using something called SF symbols. Let's remove this image view for now, and let me bring up this browser window. Now, SF symbols, they are a set of 4,400 symbols or icons on the iOS system that you can use for free because they're already installed on iOS. All you have to do is the appropriate name for these icons and you can display them. You don't need to search for any images or anything. The best thing is that they behave like text so that you can change the foreground color of them, you can change the size of them and things like that very, very easily. Let's go back into Xcode and see how we can use an SF symbol to display the stars. So just like displaying an image, we use the image view, but instead of specifying the asset library name like we have up here, we're going to specify the system name of the SF symbol. So we type in system name, that should come up, and notice that it's lowercase s, uppercase N with a colon, and then we're going to put the name of the SF symbol, and this has got to be in quotations as well. So I'm going to put star, and you can see it instantly shows up. I did not have to add this star image into our asset library or anything like that. Another really cool thing is that often these symbols come with an outline version as well as a filled version. And typically the filled version, you just have to add .fill to the end of the name, and that's what you get. Now you might be wondering, how would I know this system name? Well, that's where this comes in handy. So SF Symbols is a free download for an app that looks like this, and it allows you to either browse through the symbols or search for it. So if I search for star, I can see these are all of the system names that I can use. Look, there's star.fill, which is what we just used, and there's even this one, it's half star. Now, if you don't want to download this official app by Apple, I think in the past there were other websites which listed out all the SF symbols. You can search SF symbol browser or something like that in Google. But seeing as how this is the official Apple app, and I'm sure this will get updated first before those third-party websites do, I would recommend that you use this. So what I'm going to do now is I'm going to give Niagara Falls 4.5 stars. So I'm going to put 4 of these and 1 of these. So I'm going to actually copy this name, and that's going to copy this part down here. Let's go back to Xcode, and I am going to image system name and paste. Oops, I need quotations, right? And now I have 1.5. So all I'm going to do is copy this, paste it a couple of times so that we have there 4.5 stars. Now this doesn't look quite right as well, right? I want to push the stars all the way to the right, and they're also a little big and they're not the color that I want. So how do we address this? Well, first of all, let me explain how these elements are arranged inside an H stack. So let's go into selection mode for now so that I can select these elements and show you this outline. You'll notice that inside this H stack only goes up to here. What's happening is that this H stack is only as wide as it needs to be to fit all of the elements inside of it. Furthermore, these elements inside of it, you can see the outline is right up against the text element. Same thing with the images, right? That blue outline, that's the surrounding frame. That's how much space it takes up. It is only as big as that view needs to be. Now, this is typical of views. They only have a frame as big as it needs to be, but there are some views that actually take up as much space as it can. So that is actually what we want to put. One of these elements is called a spacer. Now this spacer view will basically take up as much space as it can. So let me demonstrate this. Again, since it's the first time we've used this, let's open up the library under views. Let's search for spacer. There we go. A flexible space that expands along the major axis of its containing stack layout, or both axes if it's not contained in the stack. Essentially, it's just saying that it's going to take up as much space as possible. Look at what happens here. By putting a spacer in between the text and the stars right here, first of all, it pushes the H stack right as wide as it can be. Because remember, the H stack expands to as much space as the elements inside of it requires. The text still requires just that bare minimum. The stars, again, requires the bare minimum, but the spacer, on the other hand, is taking up all this empty space right here. You don't see the outline, but it's right there in the middle. So the spacer is a great way to space elements apart, as its name suggests. Now, one handy tip before we move on, if you have multiple spacers in the same container, it divides up all of the available space by the number of spacers you have. So if I put a spacer before the text and after the images here, you can see that this space and this space and this space are all equal. So the spacers take up all the available space and divvies them up between each other evenly. Right, but I'm gonna remove those two. Just gonna leave the spacer element in the middle. It's gonna take everything up here. We're gonna add some padding to the left and right later anyways. Okay, so let's finish up this ratings by adding some text right below the stars. In our initial design, we had, in brackets, a couple of reviews, or the number of reviews there. So how would we do that? So I could put a piece of text right here that said text. Let's put some brackets, reviews, like that. But you can see here, it does that, not the effect that we wanted. Why not nest another layout container? So what we're going to do here, so this is an H stack, right? I'm going to put these 5 stars in a V stack so that we can put the text right under it. So let's create a V stack right here. And we are going to put the images in there. As you can see, it lays it out on top of each other as expected. And I'm going to put the review text down there as well. Now, this is sort of what I want, but I need to lay these out horizontally, right? So I'm going to nest an H stack in there. And so that actually gives me what I want. Now, the stars and the reviews text is a little large for my liking. So, and plus it's not the right color too. So I am going to add some modifiers to it. So what we're going to do is I'm going to type this out, and I encourage you to do so as well. If you don't remember, following along and typing it out is a great way to remember. So to change the color, we use foreground color, and I'm going to hit dot so we can bring up autocomplete. I'm going to choose orange. Press enter. There it is. It's orange. I am going to go to the end and hit dot again, and this time I'm going to change the font. And I'm going to hit dot again, and I'm going to choose caption to make it smaller. So that's about the size that I would want it. Now I would have to apply, let me just make some more space so it's easier to see. Yeah, perfect. Now I could apply these two things to each star like that, right? And that would essentially get me what I want. But there is a better way to do this, and that is to put these two modifiers instead on the H stack right here. Okay, watch what happens. I'm going to take off these modifiers. you can see that each of them have the orange color and the caption size. The reason for this is because modifiers on a container view get applied to all the views inside of it. That's awesome, right? So I actually want the same thing to happen to this. So instead of applying it on the H stack, why don't we put it on the V stack so that it includes this text element? So Command X, Command V. Now you can see the orange color in the caption gets applied to the whole thing. And now for the final piece of content on the card itself, and those are the icons on the lower right corner. So for this, it is pretty simple because we have this description text already in a VStack. So under here, we're going to add the icons. We're going to use SF symbols. We're going to use system name, and let's bring up our trusty app here. This is going to be, let's use binoculars, and we're going to choose the filled one. Let's copy name and paste it in there. Whoops, we need quotations like that. Those binoculars right there. Let's add another one. This one is going to be, I'm going to use a fork and knife. Copy that. And we're going to put that. We're going to put the fork and knife first. Now I'm going to put these two into an H stack. Like that. And I am going to space them so that it is on the right hand side. So all I'm going to do is add a spacer element before the two images, which pushes it all the way to the right. And finally, we are going to change the color and the size. So we're going to add a foreground of gray and a font of caption. Foreground color gray, font caption. Now you can see how typing it together with autocomplete is way faster than opening up the library each time to choose the modifiers. And again, if you're still more comfortable with doing it this way, that's completely fine. I love this new version of Xcode and SwiftUI where you can have multiple ways of doing things. You can configure things through the inspector because it makes it the learning experience much better and easier. As you progress, you'll probably be not even touching the library or the inspector panel. You'll just be typing and you'll be moving really, really fast. So don't worry if you're not there yet, you will get there if you continue to progress along this journey. Okay, so next up we have the background for this card. Now let's go ahead. This is the vertical stack, right? You can see when I select this blue outline highlights the boundaries or the frame of this V stack. So like the H stack, the V stack only takes up as much space as it needs to. So you can see that it's right up against the edge right there. So if we go down, this is the ending bracket for the V stack right here. If you're not sure, what you can do is collapse the code in between the opening bracket and the closing bracket, just so it's easier to read. So how you can do that is you press your, click your cursor here inside the V stack, and you can go into right here, code folding, and you can fold and unfold. Just take note of those shortcut keys inside Xcode so you don't need to come into this menu all the time. But I'm going to choose fold and watch what happens. See, it folds all of that stuff into these two brackets so that it's easier to work with. And then it's a visual thing. That's all it is. And if you want to open it back up, you can double click it to open it back up. And again, once you get familiar with Xcode, you don't even need to bring out that menu. You can use your keyboard and just do that, and you can move really fast. So the reason I wanted to do that is because I want to add a modifier to the V stack. And in particular, the one I want to add is, let's go under modifiers and choose background. This one right here. Layers the given view behind this view. So essentially it allows me to specify a view as a background to the V stack. So let's see how we can use this to our advantage. So this is the background for the V stack, and I wonder why it changes it to blue. I haven't even specified any view, but that was what I was going to do. So I was going to put a rectangle to be specific. So rectangle is a view You can find it actually inside the view library here. It's a simple shape that you can specify foreground color, corner radius, and things like that. So I'm going to drag and put that in between the brackets of the modifier. By default, I guess it's black. So this is where things start to get interesting. I'm going to add modifiers to the rectangle to change its look and feel. And that essentially is the background for the VStack. So let's go ahead and add a foreground color to my rectangle. So I can say, dot blue, for example, and that would be blue. You can say green, and that would be green, right? So let's leave it as green for now. We're going to change it later because if I change it to white right now, we won't be able to see it. Now, the thing is, we probably want some spacing, right? You can see this is right up against the edge. So what we're going to do is add some padding. We're just going to use the padding modifier like we've done before. And great, we have some padding between the edges of the screen and the card. But what about padding inside of the card, right? You can see the green background. We'd want some padding there. So what I'm going to do is add another padding modifier right here before the background modifier. And you can see that that's this padding right here, whereas this padding is this. Now, I know that might be a little bit confusing, but the way to think about this is that you have your VStack. This is your original view. And then these modifiers get applied in sequence. That means in order. So if you look at the code that we have right now, first we have padding. So that adds, actually, let me just remove this code for now. I'm going to press Command X so that you can see what we have. So without this padding modifier, you can see that the blue frame, right, is right there. If I add the padding element, essentially adds padding to all four sides. And now I put the background modifier on there. Let me just remove that last padding bit. Right, the background gets applied to the padding as well. And then when I put another padding modifier, it gets applied to the outside of the background. Like that. What happens if, let's say I move this padding modifier here, right? Then we get padding and then another set of padding. So that's why it's so thick. And then the background gets applied. If I take these two padding elements and I put it after the background, then we get something like this where there's no padding, right? The background gets applied to the VStack, and then you have a set of outer padding and another set of outer padding. So the order matters, sequence matters here. Okay, so now that you understand that, let's change this foreground color to white, and we're going to add another modifier to the rectangle. And let's create some space here. Dot shadow. Now I'm just going to specify 15 for the radius, and you can see that you have a nice shadow effect. That's how easy it is to apply that. Now the last thing to do is to apply a corner radius to our card. Now I don't want to apply it after the shadow. I actually want to apply it before the shadow because I want the shadow to apply to the rounded card and not round the corners of the shadow, because remember, order matters, right? So if I do corner radius 15, you can see that, let's choose this. You can see that I have the rounded corners and then the shadow gets applied. But let's say we do it the other way around, right? And I put a corner radius on the shadow. You can see it completely breaks things. So I want to round the card first and then apply the shadow to the rounded card. Essentially, this is the rectangle. We're using it as a background for that VStack. Okay, so finally, the last step is to put that mint green background on everything. And just like in lesson 1, we've done this before. So we are going to use a depth stack, right? And we're going to put a base color at the bottom, and then this whole VStack card, this whole thing on top of that color. So let's do that. If you remember, what is a depth stack? It is a Z stack, like that. I'm going to put a color. I'm going to choose mint, system mint, okay. And again, this is the safe area, right? So we have to apply another modifier to it. So ignores safe area. So it goes all the way. And then what we're going to do is we're going to put the V stack on top of it. So this whole thing right here, and keep in mind this is still collapsed, which also makes it easy to select. Command X, Command V to paste it inside the Z stack. So there you have it.
So how was that? As you build more user interfaces inside Xcode, you're just going to get faster and better. Remember that you can get the associated Xcode project with this lesson, as well as any challenges and quizzes, by creating a free Code with Chris account and taking this course on our learning platform. We also have a free community where you can get help if you are stuck on something. Just visit codecrew.codewithchris.com. In the next lesson, we are going to build an app that is not just the user interface, but also includes app logic and user interaction. So it's going to be a good one. I'll see you there. Today, you're starting a brand new app that will teach you all of the basic skills for iOS app development. In this lesson, you're going to be building the user interface for that app. And then in the following lessons, I'm going to take you through the coding part so that you can add the logic and user interactivity to the app. Now, hopefully you've been following since lesson 1. And if you've been learning a lot, please show your appreciation by giving this video a thumbs up and consider subscribing so that you don't miss the next lesson. All right, buckle up, let's go.
Okay, let's go ahead and start a new Xcode project. Go to File, New, and let's choose Project. And then under iOS, we are going to select App. Now by this time, this should start feeling pretty familiar to you. I'm going to call this the War Card game. Now, this time, we are going to come back to this project over several lessons. So make sure you name it something that you like and also save it in a location that you can remember, because you're going to need to launch this project again. So you don't need to change anything with team, organization, identifier. Interface should still be SwiftUI and language should still be Swift. You don't need to check any of the other options. Let's click next. I'm going to save it on my desktop so it's easy to find. You don't need to create a Git repository for this. Let's just hit create. And if you don't know what any of those options are, I would suggest you review lesson 2 because that's where we went through all of those options. Let me adjust this window just a little bit so we can see what's going on. And I'll shrink that a little bit and we will actually get rid of that inspector tab. Next, we're going to add the image assets that we're going to need for this War Card game. So I've got the assets ready to go here in this folder. In the video description below, you'll find a link to a War Card game imageassets.zip file. If you unzip it, you'll see the same image assets. Now, if you're on desktop, you might need to expand the video description that's underneath the title in order to see the link. And if you're on mobile watching this on YouTube, you might need to tap on the title of the video to open up the video description, and then you can find the link. Once you have that zip file unzipped and you have all these assets staring back at you, I want you to highlight all of them. Notice that they're organized by folder, and those folders are going to be preserved when we bring them into our asset library. So in Xcode, let's go ahead and click on assets. And then back here, we're going to drag this and just drop it in there. You're going to see that this is preserved. And so it's really nicely organized. And if you've worked with iOS app development before, you might have seen that we did 3 different file sizes. However, these images, if you notice, they are SVG format. This is a special vector format where you can scale up and down these image assets without any loss of quality. So that's really neat, and we only need to have this one size here. Okay, after you've done that, let's take a look at the UI that we're trying to build. Now, based on what you've learned in the previous lesson, how would you break this user interface up in terms of what view containers or layout containers, if you want to call them that, which one of those are you going to use to lay out these elements? And second of all, which view elements are you going to use to represent each of these things that you see?
Now, as an exercise, I want you to pause this video and try building this UI yourself inside Xcode. Trust me, by doing this exercise, you are going to cement your skills and you're going to identify what you need to review. Now, before you start this challenge, if you haven't watched the previous lesson, you can do so right over there. It's going to show you all the skills and techniques you need to accomplish this right now.
Now for each of the elements that you see in the UI right here, I want you to just use a SwiftUI view element to display the images that you've just added to the project. Now in terms of which view containers you want to use in order to lay out these different views, it's all stuff that you've used in lesson 3. So there are no surprises. And here are also some view modifiers that might come in handy. So pause the video now and try it out, and then resume it when you're ready to build it together.
All right, how was it? Now, if you got it to look relatively the same, that's a win in my books. But if you struggled, that's also a good thing, because as you follow along and we're gonna walk through it together, you're gonna have context, and that makes a huge, big difference. All right, let's do it.
Okay, here's what I see. We have a depth stack as the root element, also known as a Z stack or Z stack. And then we have an image, which represents the background. And then on top of the background, we have a V stack, which is going to contain everything, all of the elements that you see on the screen. Inside that V stack, first we're going to have the logo centered. And then below the logo, we're going to have an H stack containing 2 cards. And then below the H stack, we are going to have the button. And then below that, we're going to have another H stack. Inside that H stack will contain 2 V stacks. Each of the V stacks will contain 2 text elements representing the player label as well as the score. And then it's just a matter of adding spacers and padding to make sure everything looks nice and spaced out. Now, if you did it another way, that's perfectly fine too. Okay, let's implement this in Xcode. Okay, so here back in Xcode, make sure you have all these image assets added to the project if you haven't already. And let's go into the content view. Here we see the preview. This is all the default stuff. Let's get rid of that. Make sure you don't accidentally delete that bracket, or else Xcode will be complaining. So you should have 2 opening brackets and 2 closing brackets right here. So I'm going to type out my view containers and views. You can feel free to use the library, just like I had shown you back there, if you haven't gotten familiar with just typing it out. Nothing wrong with that. So here we have our Z stack. I'm going to add an image, and this is going to represent our background. So I'm going to put background plain. That's the one. You could try out different ones. You could try out texture, for example. Wasn't that? Oh, it's called cloth. Sorry. No wonder. Cloth, wood, cartoon. I think this one was called. Yeah. Notice though, before I said that the image doesn't reach over here and over here. Those are, the safe area, right? Unless we put the modifier ignore safe area. So why is the image reaching all the way there now? And that is because it's displaying the image at its full size. All right, because we haven't added the resizable modifier to it. If we did, it would actually resize the image to fit the screen. So that's why the image is going full screen, because the image is actually larger. The native size of that image is larger than the screen size. So first of all, I'm going to go back to plain, and then I'm going to do resizable. And you can see as soon as we do that, we're allowing SwiftUI to resize that image to fit the screen. And you can see that it doesn't go past the safe area. So we're going to have to add ignore safe area. Now for this type of background, it doesn't really matter even if it's, way too large for the screen, because you can't really tell. But if it's a landscape image like we had for the Niagara Falls image in lesson 1, 2, 3, lesson 3, you would see that it's like super zoomed in, right? So that's why we would have to add the resizable. And then if you wanted to cover the whole screen, you would do ignore safe area. Okay, so that's that. This VStack next is going to contain all of our elements. Like I said, first up is the logo. And there it is, beautiful logo. And then we have an H stack containing the 2 cards. So H-stack, remember, lays things out side by side. So inside the H-stack, we're going to have two cards. So I'm going to use card 2 and card 3. And there's a strategic reason why we named these the way we have. Card 2, 3, 4, 5, all the way up to card 14 for the ace. You will see when we get to the later lessons where I show you some of the code and some of the logic, and you're going to learn how to apply that. Don't worry if you've never coded before. It's going to be really simple, I promise you. But naming the cards this way is going to make it easier for us as well. Next up we have, I'm just going to use images for now. For all of these elements, we have the button, right? And then we have the scores. Now, a single score looks like this. Player, and then the score, right? But there were two of them, right? So what I'm going to do is create an H stack, right? I'm going to put the player label and player score inside that H stack, and then I'm going to copy this and paste it, Command C, Command V to copy and paste, and then this is CPU. And there you have it. These are all of the elements that are on the UI. Now we just have to space them out. One of the easiest ways to space things out proportionately is to use spacers. Remember, a spacer takes up all available space. If there are multiple spacers, it divides the space up between them evenly. So, for example, if we wanted to space these items out vertically to have an equal amount of space between all of these vertical items, in this V stack here, we could put a spacer just in between everything, right here, here, right between the logo, between the card H stack, between the button, between the scores H stack. So let's try that. I'm just going to copy that and I'm going to paste it a bunch of times. So you see, just adding a single spacer, it pushes everything down because it tries to get as much space as possible. So that's a great thing to do if you want things to be bottom aligned, for example. I'm going to add a second spacer under the logo. So now you can see it splits up the space between the two spacers. I'm going to add a spacer below the card H stack. Now it's divided by the three spacers. I'm going to put another spacer below the button. There you go. And finally, another spacer below the scores. So now everything is spaced out vertically, evenly. For these cards, I want to do the same thing. For the H stack, I'm going to put a spacer in between the two cards, which pushes them off to the side. But guess what? We're going to add a spacer to the left of that card and to the right of that card. And now they are spaced out evenly horizontally. Now we're going to do the same thing for the scores. We're going to add in this H stack a spacer like that, which pushes out to the side. Again, we're going to add a spacer to the left and to the right, so it divides the space up evenly. There we go. Now we're going to change some of the font colors and sizes. So why don't we first make everything white, the font white. Now I could apply them to each text element, but remember, if you apply the modifier to a view container, it affects all of the views inside of it. So I'm going to take a look at which outer parent view container contains all of those text elements, which happens to be this H stack, right? I could put on this V stack and this V stack, but if I put it on the H stack, then it applies to everything inside and I only have to do it once. So let's do foreground color dot white. You can see that all that turns white. It gets applied to that, and that, all four text elements. Now this time for sizing, I have to apply it to the individual text elements because I want them to, they're going to look a little different for each one. For the player, I am going to do font and I'm going to say dot headline. It's going to bold it a little bit. Same thing for the CPU label, font headline. It's going to make it a little bigger. For the score, I'm going to do font dot large title. Same thing for here, font dot large title. And then lastly, I want to add a little bit of space underneath the player label. So I'm going to add a second modifier under there. And this time, instead of just adding padding, which does padding on all four sides, what you can do here, instead of just writing out the code, sometimes if you don't know the code representation of something that you want to do, you can always open up the inspector panel and you can take a look at what's happening. So for this player label, padding is being applied on all four sides. You can see here, padding is all four sides. I can hit X to get rid of the padding. Actually, that deleted it. And I can check just the bottom padding. And I can increase it to 10. So that's just going to pad the CPU. No, it didn't apply it. What did I apply that to? Okay, so you got to be a little careful doing that. Let me just hit X on that. I think I applied it. Sorry, I applied it to this. I'm going to put my cursor over the player label. I'm going to hit bottom. Now you can actually see the code it added padding bottom, and I'm going to increase that to 10. By default, it's 20. Let's refresh it. There we go. So you see 10 right there, and you can see the equivalent code modifier being applied to the player label. Now I can simply copy that and I can paste it for this CPU. There you go. Awesome. That is our UI. Now, in order to apply some user interactivity to this button so that we can handle the user tapping on it, we're going to have to learn a little bit of basic Swift code.
That's why we're going to take a few lessons to get some basic coding skills, and then we're going to come back to the war card game, apply what we've learned, and bring this app to life. Now, if this is going to be your first time coding, don't be intimidated. I'm going to make this so simple for you to understand, and we are going to erase any fears that you might have. If you're excited, please give this video a thumbs up if you haven't already. I really, really appreciate it, and I'll see you in the next lesson. In the last lesson, you built this user interface, but in order to handle taps on this button to change the cards up top, we're going to need a little bit of Swift code. By the end of this lesson, you'll be writing your own Swift code statements, and you'll realize that it's not so hard to read or write. So please watch until the end. All right, let's buckle up and let's go.
First of all, let's make sure we're all on the same page. What is coding? Well, to me, it is just the act of writing out code statements which represent instructions that we want the computer to do. And then the computer reads the code statements and carries out our instructions. Well, what is Swift then? Well, Swift is the coding language that we use to write those code statements. Just like a language, for instance, English or Spanish has a structure and it has rules to follow and it allows us to express ourselves, the Swift coding language is the same. It has a structure and a grammar which we follow in order to write Swift code statements. These Swift code statements are then converted into machine code, which the computer can understand and carry out. Now you might ask, why not just write machine code and skip this extra step? Well, Swift code is easy to read, write, and to manage for us human beings, but machine code is not. So that's why we need this step. Now the thing that converts the high-level code, like Swift code, to machine code is called a compiler. In this case, with building iOS apps, Xcode performs this compilation step.
Now that you understand what it is, let's try writing some Swift code statements of our own. And I know the perfect place to do this.
We're going to experiment with some Swift code in something called Xcode Playgrounds. Now, if you're brand new to this video series, we downloaded and installed Xcode back in lesson 1. So if you don't have Xcode ready yet, just go ahead and watch lesson 1 right over there and come back to this lesson when you have Xcode ready to go. Now, a playground is a lightweight way for us to practice with and experiment with Swift code without creating a brand new app project, which has a ton of views already set up for you and things that we don't need. So here's how we can create our playground. Make sure that Xcode is in focus. You can click on Xcode dialog window right here, go up to File, and then go New and choose Playground. You're going to get something like this. Now we are going to go under iOS and we're going to choose blank. And that's going to be the most basic of basic playgrounds for us to test our code with. Click on Next, and we are going to save this somewhere. I'm just going to call this Swift code playground. You can call it whatever you'd like, as we're just going to use it to test some code. Okay, so now, first of all, I'm going to close this left-hand navigator because we don't need that by clicking that button. And then I'm going to make this window a little larger so we can see what we're working with. Okay, so if you're following along, you should have something that looks like this. Now in this brand new playground, we have this single Swift statement. You can ignore the import statement for now. Let's focus on this line of Swift code and let's see what that does. var greeting equals hello playground. Let's dissect this Swift statement. First of all, we're going to talk about this hello playground part on the right hand side of the statement. Now this is a piece of text data and you've seen this before. In the user interface that you've previously built, I've highlighted the pieces of text data here. Now it shouldn't really surprise you. Apps are all about manipulating data, pulling data from various sources, manipulating that data, showing that data to users through the app user interface, interacting, capturing user interaction as data, and then processing that, storing data and retrieving data to and from databases, and so on and so forth. Later on in this lesson, we're going to talk about different types of data that you can work with. But for now, let's go back to the code statement. This is a piece of text data. I want to ask you a question. Where does this piece of text data live? Or in other words, where does it exist? Well, it exists in the computer's memory. This is memory space that is allocated for our app to function. Okay, great. Now, how do we refer to this piece of data in the memory so that we can work with it and manipulate it? So walk with me through this scenario. Imagine you have your first Swift code statement that creates this piece of data in the computer's memory. In your second Swift code statement, let's say you want to work with this piece of data. Perhaps you want to manipulate that text data, change it to all capitals, or maybe you want to take it to display it on the user interface or something like that. But how do you retrieve it and access it from the computer's memory? We need some way to be able to access and reference that piece of data in memory. And this is where the rest of that Swift code statement comes in. Let's go back to it. This is a variable, and it is something that allows us to keep a reference to something else. Think about it like a sticky label that you can stick on a piece of data. In this case, our variable, or label if you want to think about it that way, is called greeting. And the equal sign is what is called an assignment operator. Now, its job is to assign the data on the right-hand side to the variable on the left-hand side. It's like the process of sticking that label onto that piece of data. Right here, var is a special Swift keyword, and what it does is create a new variable. So if you read this entire Swift code statement from left to right, these are the instructions it would be giving to the computer when the computer executes it. So starting from the left, first of all, create a variable named greeting. Next, assign to this variable the piece of text data, hello playground. Now, after this code statement is run, we now have a way to refer to that piece of text data in memory. Anytime we want to get access to it, we just have to use the variable name. In this case, that is greeting. In fact, take a look at this second line. This code statement prints out the text data. Let's see how we can try this out on the playground. The Xcode playground has a way for us to run or execute the code to see what the results are or the output. So here in the lower left hand corner, you'll find this small play button. And if you tap on that, it's going to execute the playground. Now, the first time you tap on it, you can check the status bar. It'll tell you it's running. And after you click it, you're going to see the output. Now, right here, you won't see anything aside from something appearing over there because we haven't printed anything out. But in the lower right hand corner, you see this other button. This brings up this little window down here, and this is called the console area. This is where output will happen. So let's go ahead and write that second print statement and try out printing out our variable. So I'm going to type in print, open bracket, greeting. Remember, this variable is going to reference hello playground. So let me hit stop here and hit execute again. And this time it's going to run both lines of code starting from line 3 and then line 4. And you're going to see the result of line 4 printing out the text data into the console here. Now I want you to notice something. In line 3, we had the var keyword, but then in line 4, when we wanted to use that variable, we did not have to use the var keyword again, because remember, this var keyword is a special Swift keyword to create a new variable. In line 4, we're not creating a new variable. We are simply calling it and using the data that it references. That's why we don't use the var keyword there. Now, if you want to use proper terminology, this process of using the var keyword to create a new variable is actually called declaring a new variable. Now, I only use the word creating because in my experience teaching this, creating makes more sense to beginners. But now that I've explained this to you, I'm going to start using the word declaring just so that in the future, if you learn from different other training materials, you won't get confused when you see them saying declaring. Now I want to show you something cool about variables. Remember that analogy about the variable being like a label that you can stick on data? Well, just like labels, how you can peel it off something and stick it on something else, you can do the same thing with variables. So in fact, I can assign something else to my variable. So let me reference the variable like that. Notice I don't have to use var again because I only need to create it once at the very beginning. So greeting, I'm going to use the assignment operator, and I am going to assign another piece of data, a different piece of data to it. Like that. Now, if I moved my print statement, so let me Command X to cut it, paste it here, Command V. Now, if I do that, what do you think this is going to print out? Let's go ahead and try it out. So I'm going to hit stop and then hit run. And it prints out I can write Swift because this has now assigned to my greeting variable, the piece of text data, I can write Swift. Now what happens to the first piece of text data, hello playground? Well, the computer will detect if nothing else needs to use that piece of data, it's going to clear it out from memory. Now I mentioned before that there are different types of data that you can work with. So here's a list. Now it's not exhaustive, but these are the most common and basic data types that you will begin working with. So first of all, let's talk about the string data type. This is what we've been working with so far. It's text data. I know that's a little bit of a weird term, but think of it as a string of characters. And in fact, this is the terminology for text data across most programming languages. So when you hear string, think of text. Next up, we have int and double. So int represents integer data. So those are like whole numbers, including negatives, and doubles are decimal numbers or fractional numbers. Boolean, or bool for short, stands for true, false, that type of thing. This data type is useful when there are only two options like a light switch on or off. Now let's go into our playground and let's try out some of these data types. All right, so first of all, let's try out the numbers because we already did strings. Like this is a string right here. So that's text data. So let's try out an int. 5. We'll print out my int. Notice I'm using the var keyword to create a brand new variable called my int, and I'm assigning to it the integer 5. And then I'm printing that. Let's see what we get in the console window. So we get that 5. All right, let's try to look at my double. I'm just going to create the Boolean too. Now you'll notice as I'm typing, autocomplete pops up, and this is something in Xcode that helps you. Xcode can detect what sort of variables you have, and as you're typing, as I'm typing my, I can narrow down, it narrows down the list to some possible selections, and I don't have to type out the rest of it. I can just move down, press enter, and there we go. So let's go ahead and execute this, run this, and see what we get. All right, so there's our string data, there's our integer data, there's our double data, and there is our Boolean data. So the just in case you didn't know, that is going to be the flip side of false. It's just going to be true. All right, next up, now that you know about data types, I need to mention that when you declare a new variable, you also need to specify what data type it is going to be referencing. Now you might be saying, that's not true. Here's the thing. We've been using a short form to declare these variables right here. Here is the actual way. After the variable name, you put a colon followed by the data type that is to be expected that this variable will be referencing, whether that's string, int, double, bool, or something else. Now here's the kicker. Variables can only store data of the same type that you declared for that variable. Now you might be thinking, looking at this playground, where have I declared any data types in these variable declarations? None of them have that colon data type. Well, what's happening here is a shorthand. I don't have to say what type of data it'll hold, but the system will look at what type of data I'm assigning to it, and then it's going to know, oh, okay, so this greeting variable is actually a string data type variable. This, my int, it looks at this data that I'm assigning to it for the very first time, and it's going to know, oh, this is an int data type variable. So the same thing goes for the other variables. This is going to be a double. This is going to be bool. Now, why is this important to know? Well, let me show you an example. For this variable greeting, it is of the string data type. So I can assign these two pieces of string to it. In fact, I can reassign another piece of text data to it. However, let's say I try to assign an integer to it. We're going to, if we try to run this, we're going to get an error. Cannot assign value of type int, which is this, to type string, which is the greeting. Now, even if we do not declare the data type up here, so let me just get rid of that and let me run it again, it will still end up with the same error because the first time you assign data to that variable, you're locking in the type. It's going to look at this and it's going to say, this is string data type. This is going to be a string data type variable. And that's what it is from that point on. Okay, so that's just something that is important to know. Now, one last thing I want to show you before we move on from this lesson is something called a constant. Now, constants are a special type of variable. Instead of using the var keyword to declare a new variable, we use the let keyword to declare a new constant. Now, everything about a constant is the same as a variable, from how it's used to how it's declared and how it can only store data of the same data type as what you declare it with. Now, the only difference, there's one single difference, and that is that with a constant, you cannot reassign data to it. Once you assign data to it, it is constant. All right, you're guaranteed that that is the piece of data that it's affixed to. Think of it as like a label, but instead of just sticking it on the piece of data, you are super gluing it on with some industrial grade stuff and you cannot rip it off. Okay, that is like a constant. So let's go back to the playground and let's try this out. So for example, if I change this var for the greeting variable to a let, that changes it to a constant. We're gonna get an error here because we cannot assign a value. Greeting is a let constant. We've already assigned it this value, so we cannot reassign it. However, if I change my int to a let constant, this is going to be perfectly fine. I can run this and it's going to produce output. However, if I try to reassign something to that label, let's say 40, we are going to get an error. Now you might wonder, why would we ever want to use a let instead of a var? Well, the reason is that variables have special allowances in memory, some stuff under the hood that gives us this flexibility, but it comes at the cost of not being as efficient or optimized as a constant. So if you know something is not going to change, or you want the assurance that it will never change as you are using your constant, then you should use the let keyword. And in fact, Xcode will help you optimize this. If you use var keywords and Xcode detects that, hey, you've never reassigned anything into this variable. Why not use a let? And it's going to prompt you as you're coding in an actual app project. It's going to prompt you, why don't you change this var to a let instead? Because it's not going to impact anything. And in fact, under the hood, there's going to be a teensy bit of optimization.
Congrats on writing your first Swift code statements. If you're learning a lot from this video series, please support me by giving this video a thumbs up. And if you're not shy, please drop a comment below and let me know whether or not you were able to follow along. This diagram sums up what you've learned today. You learned about what variables are, how to declare them, and how to use them. You learned about data types, and finally, you also learned about constants. Great progress today. We are going to continue learning Swift, and we're getting closer and closer to going back to that work hard game and adding user interaction. In this lesson, you learned about code statements. In the next lesson, we're going to learn how to batch these code statements up so that we can execute them as a group, so that we can assign that group to the button tap on the work hard game. And that is how we are making our way towards adding interactivity to that work hard game. And I'll see you there. In the last lesson, you wrote your first Swift code statements. In this lesson, you're going to learn how to group together code statements to perform a task. Now, these groupings of code statements are called functions. This is a very powerful concept because you can execute or call these functions whenever you want to perform that task. Let's dive in and see how we can write our first function.
Okay, so first of all, how do you declare a brand new function? Now, this is going to look somewhat similar to declaring a new variable or constant. It's a keyword followed by a name. So in this case of a function, the keyword to use is func, or func for short. And then followed by that, you put the name of the function. Now, just like a variable name, you are going to be referring to this function name in order to execute the contents of the function. Now, after the function name, you're going to have two rounded brackets. We're going to ignore these for now, but these two brackets, they are part of the name. And then following that, you have a set of curly brackets. And you're going to find most of the time in Swift, when you see a pair of curly brackets, it's code that goes in between those two brackets. In this case of a function, that is where we are going to put our grouping of code statements. So whatever code statements you want this function to run when you call it, you are going to put those code statements in between those two curly brackets. Okay, so let's put some code in there and see what it looks like. You probably remember these two lines of code from the previous lesson. If we put those two lines of code into our function and we change the name to say hello, it's going to look like this. Okay, so how do we call this function so that we can execute its code? We simply use the function's name, say hello, followed by the two rounded brackets, because that is also part of the function's name. Notice that we don't need to use the func keyword again, because that was only for declaring a new function. So just like that, you are able to execute all of the code inside that function. Now, why don't we try it out in an Xcode playground so you can see it in action? So here I am with a brand new empty aside from the default code, Xcode playground. We have our var greeting equals hello playground string. And why don't we put in our second line, which is print greeting. And just like you saw in the previous lesson, when we run this, we are going to get that output in the playground right there. Now, let us declare a brand new function using the func keyword, followed by the function name, say hello, followed by two rounded brackets, followed by a pair of curly brackets. And oftentimes when you write these brackets, you'll find that Xcode helps you complete them. So let me just go back for a second. By holding Shift and hitting square bracket. So on my keyboard, that's how I get the curly brackets. Shift and do that. If I hit enter, it's automatically going to create a new line, and it's going to create that closing bracket for me. In here, I am going to take these two lines of code. I'm going to press Command X to cut it and Command V to paste it in there. And let's run our playground and see what happens. So as expected, nothing happens because all we've done here is we've declared this function, say hello, and we've put in the code in between the brackets. it's not going to run this code unless we call the function. So if I start typing my function, this menu pops up. This is called an autocomplete menu, if I didn't mention that in the previous lesson. And this just helps you write code faster. You can just select it. It's Xcode being intelligent, right? So you could type this out if you want, but notice this is the function name, right? Followed by the 2 rounded brackets, because that is part of the function name, and you'll soon find out why. Okay, but for now, let me run the code again and see what happens. Now this time I get the output in the console because this line of code is calling the function, which is executing the code in there. Now, if I call the function again, it's going to execute those 2 lines of code again. So you can see this is really powerful because oftentimes to perform a task, it's multiple lines of code working together to achieve a common result. And let's say there's 10, 20 lines of code. By putting it in a function, not only can you run that task whenever you want, but it also saves you from repeatedly writing the same code. And when you get to writing larger pieces of software, not repeating code is actually pretty important, because if you find an error in one instance of that repeated code, you don't have to go and fix it in all the other places you repeated that code. By putting it in a function once and calling it, from wherever you need to call it, you can edit the code and fix it from one place.
Now that's pretty handy, right? If you like that, you'll be even more impressed with this next part.
Now to take it a step further, functions can be even more useful because they can accept input into the function when you call it. And that is what the 2 rounded brackets is for, that comes after the function name. In between those 2 rounded brackets, you can put a series of what looks like variable declarations. If you take a look at this slide here, in between the 2 rounded brackets, I have m:string. Now what this is doing is declaring what's called a parameter for the function. This means that whenever I call the say hello function, I also need to supply the function a piece of string data. And then inside my function, within the 2 curly brackets, I can work with that piece of data, and I can reference that piece of data using the parameter name, which in this case is m. So you can imagine with this code now, whenever the say hello function is called, it also needs to be supplied with a piece of string data, which we can reference using m. And then within the function, we have the code print m. So in essence, this function serves the purpose of outputting or printing to the console whatever piece of string data you pass to the function. So let's try that out in the playground here. So instead of saying var greeting, I'm going to erase that line right there. And I'm going to declare a parameter of my function. Let's use m:string. This pretty much is a variable declaration, right? Except without the var keyword. But the proper terminology is this is a parameter of the function. You can only use m inside these 2 curly brackets. So we also need to modify our code here because there's no concept of what is a greeting now because we just deleted that variable. So let's print out m. And now you can see when we make these function calls, say hello, Xcode recognizes that, hey, if you were to call this function the way that you declared it, you need to supply a piece of string data. So it's saying it's missing the argument for parameter m in the call. So let's take a look at what that looks like. I'm going to erase those 2 function calls and I'm going to type it out again. Now, notice this time autocomplete detects that you need to supply a string data, and this is what that looks like. So I'm going to press enter. And this is where I would supply that piece of string data. And notice that it tells you that this is going to be the parameter name. When you're building this for real, you would probably use a more descriptive parameter name than just m. So you might say message, for example, and it would make more sense as you're supplying the string data. But we'll leave it as m because to follow the example in the slide, I'm going to say I can code functions. Okay, let's run the code and see what happens. So as we expect, it prints out I can code functions because this piece of string data is being passed into the function as a parameter, and it can be referenced by this parameter label m, and then I am printing it out right there. I have a reference to m from within the curly brackets, but outside of the function declaration, it doesn't know what m is, right? If I try to print m like that, it cannot find m in this scope. This is called a scope. So you can think of the area between these two curly brackets as a standalone scope or standalone area. And only in that area does this parameter exist in there, that you can reference it using m. Now going back to our diagrams for a section, what does it look like to have multiple parameters for a function? Because oftentimes we may require multiple inputs. All it is simply is you declare your parameters separated by a comma. In this example, we have the same m parameter followed by a comma and then an n parameter. Notice that this parameter data type is different. It's an int, so it expects integer data. Now, whenever we call say hello, we need to supply a piece of string data and a piece of integer data. Let's go back to the playground and try this out. So instead of modifying this function, I am going to declare a new one. And this one, let's say, does addition. And you haven't seen addition yet, so this will be interesting. So let's declare our first parameter a is an integer, followed by comma, so that I can declare the second parameter in this list, and it will be also an int, and I'll call that b. Okay, and then I have the opening curly bracket. I hit enter, it fills in the closing curly bracket, and inside here I am going to put the code. And what I'm going to do in here is I'm going to add up a and b and then print it out to the console. So I'm going to say var sum equals a plus b, and then I'm going to print out the sum. So you should be able to recognize this code. Var is declaring a new variable named sum. Equal is assigning this, the right-hand side, to the variable sum. And this plus symbol, as you can guess, adds two integers together. So we just have a plus b. But a and b are parameters that get passed in to this function call. All right, so let's try this out. I'm going to call this function doAdd, and Xcode finds it on the menu. So I'm just going to hit enter to auto-complete that. And all I have to do now is fill in the two integers that I need to pass in. So let's say 2 and 3. Let's run the code, see what happens. As expected, it prints out 5. So that is an example of providing single inputs and multiple inputs into a function. Now let us go back to the slides and extend it even more. Now functions can be made even better because functions have the ability to return output when you call them. Let's take a look at how this looks like. If you look at this syntax, notice that after the function name, after the rounded brackets, we have a dash followed by a greater than sign, which makes it look like an arrow, right? In fact, that is to signify that this function returns something, like it produces some sort of output. And then followed by that makeshift arrow, we have the data type of the data that this function produces. In this case, I'm going to put int because I want to return or output a sum. And then within the curly brackets of the function, you have to make sure that you have the return keyword, because if you've specified that this function is going to produce some sort of output, then you have to use that return keyword and actually produce the output that this function returns. And you also have to make sure that what you are returning, the output data, matches the data type that you have said this function will return. In this case, I've indicated that doAdd will return an int data, and inside the body of my function, I'm returning a piece of int data. So all is well. Now, before we go into Xcode Playgrounds to try this out, let's combine this with input parameters and see what that looks like. So if you take a look at this slide, I have two input parameters, A and B. They're both integer types. They're separated by a comma in this parameter list. And then after the rounded brackets, I have that arrow, and I am specifying that I'm going to be returning an int data. In the body of my function, I am adding up the two inputs into a variable called sum, and then I have the return keyword, and I'm returning that sum as an output of the function. Let's take a look at this in action in our playground. So let's modify our doAdd function here. I'm going to put a space after the rounded brackets. I am going to hit dash greater than space, and then I'm going to say that this returns int data. Now Xcode is going to complain here because it detects that I've indicated I should return int data, but I'm missing the return keyword for an expected int data. So instead of printing this out, I'm actually going to say return sum, just like in our slides. Now let's run this code and see what happens. Notice here that I am calling that doAdd function, and I'm passing in 2 and 3 as my input parameters. Now there is no output. Nothing pops out in the console. Why is that? Because we don't actually have a print statement that outputs it to the console. You might argue, but we're returning the data from here. Well, returning the data doesn't mean printing it out. Returning the data means that this function produces that output. But where does it go? Well, what we have to do is we have to declare either a constant or variable to refer to that output. So here's what we're going to do. I'm going to declare a constant this time. I'm going to say let result equals the output of doAdd. Right. So what's going to happen here when I execute this function and it produces that sum and it returns it, that output is going to get assigned to my constant result. If I run it right now, there also is no output. Well, why is that? Because in this line of code, I've merely kept track of the sum. So now I can refer to that piece of data. I still, at the end of the day, need to print it out. So I'm going to write print result here. Now I did this so I can illustrate to you how it's different printing it inside the function versus returning it out of the function and then capturing it, capturing a reference to it with a constant or a variable and then working with it. Now, you might say that's redundant. I could have printed it inside the function, and that's true, but I mean, this is a really small scenario, right? This is important because sometimes you may need the output to further work with it. Maybe you might want to pass that result into a second function. You might want to work with it in some way, not just simply print it out, right?
With the ability to take input and to produce output, functions can truly live up to their name and help us group together sets of instructions.
Now, there are a couple more things I want to show you about functions before we are done with them. One is called a parameter label. So when we declared parameters here for our doAdd function, what we could have also done right before the parameter name, you can put a label. So you can say, let's say first num, and before parameter b, you could do the same thing. You could put another label, second num. Let's take a look at what that does to our function call. Now I am going to erase this line of code here, and we're going to type doAdd, and this time take a look at what autocomplete suggests for us. It is now using the parameter labels instead of the actual parameter names. It functionally, the function works exactly the same way. So if I put 3 and 8 here, and then I run the function, it's going to output 8. The only difference now is by putting these parameter labels in front of the parameter names, it is going to change how you call the function. The reason for doing this, there may be multiple reasons, right? One could be you want words that are more descriptive so that when you're calling your function, you remember what data you are supplying for it. This also allows you to notice inside your function, you are still referencing them by the parameter names itself. So that's something you can use to make your functions a little more intuitive as you're reading them and using them. Something else you can do is, if you don't want to have these at all, right? If you don't want to put labels or parameter names at all, you can replace your parameter labels with a simple underscore. You can do this with one, you can do this with both, it doesn't matter. Let me just do it for both and show you what that looks like. So I'm going to type do add again, and this time take a look at what it shows up as. So you'll still see that parameter name here, but when you're now adding your data, notice that you don't see any parameter names in the function call. You also don't see any parameter labels in the function call. So this might be good for very intuitive function names. So do add, you pass in 2 numbers, very obvious what that's going to do. Or it could be to shorten the function calls itself, or things like that. And the last thing I want to mention to you is, what is a function signature? And just like a written signature, a function signature is used to identify a function. And that consists of the function name as well as its parameter list, including argument labels and such. It may seem pretty obvious, but let me introduce a scenario to you. So if I have another function called do add, and this is going to be that, right? And maybe this is, I don't know, maybe a plus b plus b, and then return the sum. So obviously the calculations are a little bit different, like what each function does, but they're both called do add, and they both have parameters a and b. So what is the function signature? Well, the function signature of this one up here, do add, is that, and the function signature of this one is this, right? Like this one is this, and this one is this. So they're different, and it is a combination of function name, like how you are using those parameter labels, plus the parameter names itself, if that is even a factor. Now, in terms of the topics covered today, I would say declaring functions, function inputs and outputs are the most important thing. Parameter labels and function signatures are nice to know, especially when you get to reading Swift code, and you won't get confused about why some things look the way that they do. But yeah, all of that combined is a good working knowledge of Swift functions.
I hope that with these 2 lessons, you're starting to realize that coding is completely within reach for you. Now, if you're learning a lot from these lessons, please give this video a thumbs up and don't forget to subscribe so you don't miss the next lesson. Now, with functions under our belt, we are able to execute a batch of code to change the cards up top when the user taps on the deal button. And you're going to learn that in the next lesson. I'll see you there. All right, we're back in the war card game, and now we're going to add functionality to the deal button so that the user can tap on it. Now, if you're brand new to this series, click over here to start from lesson 1. All right, let's dive in.
All right, so here we are in Xcode looking at our war card game. Just to give you a reminder, let's just run it quickly and see what we can do with it. All right, so here it is. It launches in the simulator. We can see the cards. This button is not interactive because it is actually just an image right now. And these are the score labels. So going into the code that represents that user interface, if we scroll down, we're going to see our image element that represents that button right there. What we want to do is change that into an actual button, not just an image, right? So what I'm going to do is create some space here so we can work and you can clearly see what we're doing. I'm going to get rid of that image element, and that's going to disappear as soon as we make this preview live. There we go. What we're going to do is first add a button from the library. So if you remember, that is this plus icon up here. If you click that and you go under this first tab, which is a library of all the views, and button should be at the top. If it's not, you can always type in button. So we're going to drag and drop that right there. Now, this is a basic text button, and I know it's a little bit hard to see there in the UI, but we're going to start with just a simple text button to demonstrate how it works, and then we are going to customize that with the image, the deal image. Let's change this string. Remember, it's a string data type. It's a piece of text. We are going to customize that into deal. And now notice that there are a pair of curly brackets here. And in between those brackets, you put the code that you want to be executed when the user taps on that button. So why don't we go ahead and just put a simple print statement. And we are going to just print out deal cards. Now, when we tap on the button, when it prints this out, it will print it out into the console area. That is down here in Xcode. So let me just drag this window up here. It's got all sorts of information. Now, if you don't see this part right here, here's the button that you would click on. In the lower right-hand corner, you would see this little button here. You click it to bring up this debug area. And if you don't see two different sides to it, there are two buttons again in the lower right that you can turn on and off. So make sure that this side with all the text, that's the right hand side, that is toggled on, because that's where this is going to print out to. So why don't we again run this in the simulator? Actually, before we do that, let me just add a simple modifier so that this text button is more visible, because right now this blue text is really hard to see against the green background. Now, do you remember how to add a modifier? So you could very simply hit dot and then foreground color, and you can type in dot white to change that to white. Or if you didn't want to do that, you could always go through the library by hitting this plus icon, choosing the modifiers, and selecting foreground color, clicking and dragging right there, changing that default blue text to white. All right, let's go ahead and rerun this in the simulator. All right, so here's the simulator. I'm going to tap on this button and it's going to run this code right here, print deal cards. As you can see, it is starting, each time I press it, it executes the code within those curly brackets. So great. Our button works. Now, the next thing I want to do is to incorporate what you learned about functions. So instead of simply writing the code here inside of these two curly brackets, why don't we call a function from here? So this function is going to perform all the code related to dealing cards. So why don't we find a space to put this function? So this part you have to be kind of careful about where to put this function, because I haven't really explained yet what these structs are and where you would put your functions. So I'm going to tell you where to do that now, but it's very easy to make a mistake. So here's what I want you to do. So put your cursor, let's say right under body right there, and you're going to go to editor, and you're going to go to code folding, and you're going to hit fold. You can also take note of these shortcut keys if you'd like. So we're just going to choose fold, and that's going to fold it all up neatly. If you want to unfold it, again, you can either double click this. Actually, you could double click that to open up. That's probably the easiest way. So again, put your cursor under body. If you don't have a blank space here, and you could do it there, all you need to do is actually make sure that your cursor is after that opening curly bracket of the body. And we're going to go to editor. We're going to go to code folding and hit fold. And the reason I want you to do that is because we are going to create a new line right before this closing bracket, but after the closing bracket of the body right there. And we are going to declare a new function. Now, I'm going to explain to you in future lessons why we are putting this where it is, and what is a struct, how do you know where to put your functions and things like that. But for now, I just want you to follow what I'm doing. So type in func to declare a new function. We're going to call this function deal. If you remember the syntax for it, pair of parentheses, which in between there you would put in any input parameters, right, that this function expects. For the purpose of this code, we don't need any input parameters, so it's just going to be an empty pair of parentheses like that. Now let's open up a pair of curly brackets like that so that we can actually put the code in there. Now in here, I'm going to put print deal to declare a string. We got to use the quotation marks, right? Okay, so this function, all it does is print deal cards, just like what the button did before. And it'll execute this anytime you call deal. So now let's open up the body again, scroll down to our button, and instead of calling print right here, we are going to call our new function. And look at that, autocomplete recognizes it, and all we need to do is that. Now let's run it in the simulator and just test that it still works, because we don't want to make a mistake at this point. So let's tap on that button. As you can see, it still works, right? What's happening is that when you're tapping on the button, it's executing this function. If you scroll a little lower, this is what that function does, right? So now in the future, when we want to add functionality to the button right here, all we need to do is add the code in here.
So that's a basic text button, but what if we wanted to use an image for the button instead? Let's take a look at how we do that.
Let's scroll back up to our button element. As you can see here, the button that you add through the library in this way, it only allows you to specify a piece of text. So this is a text button. If you want to create a button which can be visually represented by anything you'd like, what you would have to do is type out button, type out the first opening parentheses, and you can see a couple of different options for buttons that you can create. And what we were looking for is this one right here, action and label. So action is what happens when you tap on it, and label allows you to put any sort of UI code in there, any sort of UI visual elements. So let's go ahead and double click this, and you're going to see these input parameters look a little bit different from this one, right? This one only had the one text parameter that you had to supply, and that was for the text for the button. This one has two different ones. It has action and it has label. So you can double click on any of these. So go ahead, double click on action, this part right here. And what's going to happen is it's going to change in this sort of format right here. This first set of opening bracket, this is the action for your button. So let's stay organized here. So I'm going to actually get rid of this text button first. Okay. And in here, under label, this is actually where we're going to put the visual representation, right? Label this set of curly brackets. Let's put in an image element, and our image name was button, right? If we go back to assets, that's what this is right here. Let's go back to content view and let's refresh this preview right here. Oh, okay. So we can't yet view the preview because we haven't filled in the code part yet. So you can actually just delete that code part and that will be valid. Okay, so as you can see here, we've got now a visual image of our button. And you see this is the visual representation of the button. Now in here, this is supposed to be the action. Good thing that we created a function, right? We can simply call that deal function like that. Let's now run the app in the simulator again and take a look at what happens when we tap on our new button. So you can see it is an image element, but it is actually a button. And when we tap on it, it runs the deal function, which prints out this statement in the console area.
All right, now that we have the button looking the way we want, let's add some more functionality to it.
So we want our deal button to do more than just print out deal cards. We want it to actually deal cards, right? So how is tapping on this deal button and running this deal function, right? What sort of code can we put in here to actually change the images for this image element and this image element, right? And then how are we going to update the score labels here as well? Well, let's first take a look at what represents these things and see what we can work with. We scroll up, we can see that we have an image element that represents card 2. And this is referencing the image asset in our asset library, card 2. In fact, we have card 2 all the way up to 14. So you'll notice that when I change this in here, and I update the preview, it's actually going to change the card, right? Change it to 13, right? Change this to 14. And if I accidentally change it to a name that doesn't exist, then it actually doesn't show anything. Right, so what we need to do is when the user taps on the deal button, we need to run some code statements that would change what is being passed into this image element and this image element as well. Well, if you think back at the Swift code that you have learned so far, such as variables, constants, functions, there is something that can help us here, right? What I'm referring to are variables. So why don't we go at the top here and declare some variables to represent the cards for the player and the cards for the computer. And that way, when we hit the deal button, we can change the value in those variables. Let me show you what I mean. So put your cursor in front of var and just create a couple of lines right there like that. And we are going to declare a brand new variable to store these two values right here. Instead of, this is called hard coding a string, meaning that when we just put a piece of text here, there's nothing that can refer to that piece of text to change it. So this is what's called a hard-coded value. We are now going to change that so that it can be dynamic. So we declare a new variable using var, right? And I'm going to name this variable player card. And I'm going to assign to it card, let's say 7. And then I'm going to declare another variable. Let's call this one CPU card. And I am going to assign to it card 13, that string right there. And now you can probably see where this is going. In the image element, instead of passing this hard-coded string into here, I can pass in the variable. And because the variable is referencing this string card 7, you can see that that is what this image element displays, right? And I'm going to do the same thing with this CPU card by putting in that variable, referencing that variable, and then passing it into the image element. So now you can see where we're going. When I tap on the deal button and it runs the deal function, inside the deal function, I can change the value that player card is pointing to. I can change CPU card to another string value as well, and that is going to cause the card images to change. Now, I don't want you to do that just yet because there are a couple of details that we need to go through first, but I'm just running through at a high level what our thought process is. Okay, so let's do the same thing for the scores down here, because if you remember when we built this user interface, the scores, we also used some hard-coded values. So down here under player, we hard-coded 0, and under CPU, we hard-coded another 0. Let's go up here and declare 2 more variables to store those scores. However, this time, I'm going to use an integer because that's going to make it really easy for us to add, right? We can add 1, add 2. We can perform these math operations on an integer. Let's do the same thing to represent the other score right there. And let's go down and change these text elements to refer to these variables that we just created. Okay, so here under player, instead of passing in this hard-coded 0 string, we are going to put player score. Now, you're going to see an error, and I'll tell you why. So let's change this window a little bit. It says no exact matches in call to initializer. So that doesn't really explain very much, to be honest, but I'll explain to you what the issue is. So this text element expects a text piece of data as input, as what to display, for this label. It displays text, but what we are passing into it is an integer, right? It's a number. So it doesn't know how to display that because it's only programmed, it's only built to display pieces of string data. So what we can do is we can actually convert this number, this integer data, into string data, and then, or rather, the string representation of this number. Right? So this is how we would do that. Let me get rid of this for now. We are going to create a new piece of string data, type in capital S string, and then open a pair of parentheses. And then in the center, in between it, you are going to put player score. So let's break this down. So first of all, notice that the error goes away. We're good. What we're doing is we're taking this integer and we are turning it into the string representation of that integer. So if it's, the number 10, it's going to be turned into the string 10, and then that is now passed into the text element. So everyone's happy. Let's do the same thing with this one. So we're going to type in string, pair of parentheses. In between that, we're going to put CPU score. And this is called casting. I know it's kind of a weird name, but essentially we are converting the int data to string data. And we're changing the data types. It's called casting. We're casting an int to a string. That's what's happening. All right, so now we are all set up to modify these variables, right? Player card, CPU card, player score, CPU score. We're all set to modify these variables whenever the user taps on the deal button right here inside this deal function. Here's something cool. If you right click on any function, you can jump to the definition. That's basically saying that I want to see what is inside this function. So jump, it's just going to zoom you straight down. It could be in another file even. It'll jump you directly there to see what is this deal function, right? And all we have to do is modify the code here to change those variables that we just created.
Okay, this is the home stretch. One more lesson to add the app logic and then we're done. Now, if you've been learning a lot from this series, don't forget to hit thumbs up to support this video and don't forget to subscribe so you don't miss that last lesson. I'll see you in that video. This is the final lesson. We're going to implement the app logic to randomize the cards whenever we tap on the deal button, and we're going to update the scores as well. By the end of this lesson, you're going to have a working war card game. All right, let's dive in.
Let's do a quick recap of what we have so far. When we tap on the deal button, it prints out this deal cards statement down here, but what we actually want to happen is to randomize and display two new cards right here, right? Let's dive into the code for the button and let's go from there. So we're going to scroll down and this is our view code right here. You can see this is our button element, and when you tap on it, it calls this function deal. If we scroll down a little further, you'll see this is where we've defined it and it prints out the cards. Now, what we're going to do is delete this statement and I'm going to add something that's called a comment, or some people will call it documentation, but essentially it is a little reminder that you can leave yourself that is not treated as code. So Xcode, as you can see when I type this, will treat it as this grayed out text and it's not going to be treated as code. You can just leave yourself as many notes as you want. And it's a good way to also write out the things that you're going to code. So we can say randomize the player's card, randomize the CPU's card, and we are going to, let's say, update the score. Right? That's essentially what we want to happen. When we tap on this, we want to change the cards. Depending on who wins, we are going to update the scores down here. Let's take a look at how we are going to change the cards up here. We scroll up a little bit and we take a look at our view code. We can see that we have an image element representing the player's card right here, and another image element representing the CPU card. You can see the card that is shown is driven by these two variables up here, player card and CPU card. Scroll up here, that is exactly where these things are. This string card 7 represents that. This card 13 represents that. And these are two variables. Now, one thing I haven't taught you yet is something that's called a struct. This is sort of an aside. So you don't really need to know this yet, but in the next module, we'll talk about what a struct is. And these are actually what you know as variables when they are declared inside a struct like this. This is actually also called a property, but we will get there later. So for now, you can think of them still as variables. Now, I want to point out one thing. If you notice the way that we've named these card assets here, we go into our asset library, they all have the word lowercase card followed by a number from 2 to 14. And the reason why I named it this way is because it's going to make us really easy to randomize and choose new cards when we tap on the deal button, because all we have to do is, let's say we wanted to change the player card, right, is represented by this variable right here. All we have to do is change this to card and then a random number from 2 to 14. And there is a function, a built-in function that we can use that would randomly pick a number from whatever range we want. So I'll show you how to do that. But essentially, when we tap on the deal button, all we're going to do is assign card, the string, followed by a random number from 2 to 14. And we're going to do that for player card and CPU card. And when we change the strings in these two variables, it is automatically going to be picked up by this image element here, these two image elements, and then you'll see new cards. All right, so let's go ahead and do that. So we're going to go back down to the deal button here. And let me show you what we want to do. So first of all, player card, right? So player card equals, remember, this is referencing the variable up at the top. Equal is we're going to assign something new into it. We're going to type in this word, the string card, and then we are going to attach to it a random number from 2 to 14. Now we can use the plus symbol to join together two strings. So I can do something like this, right? And that would essentially be one string, card 7. This is called string concatenation. Right? Ignore the error for now. Now, I don't really want to put 7, right? I want this to be a random number. So instead of attaching the string 7, I am going to type in int dot random, right? When you do that, capital I dot and an R, you're gonna get this. And we're gonna use this first one right here, this first function. And this is going to allow us to specify a range. And how we specify a range is we put in the lower range followed by 3 dots and then the upper range. And this will be inclusive of the lower and upper ranges. So essentially this function, this random function of int gives us 2 to 14. Now, you won't understand exactly what this code means for now, but in the next module, after I teach you about structs and classes and things like that and dot notation, this will completely make sense to you. For now, just type in int, capital I int dot random, and then type in this range. Now, you're going to get an error here. And the reason why this error is occurring is, for one, there's two errors here, actually. The first error is because when you're trying to do that string concatenation I was telling you about, it has to be two strings. Right here, we have the card string, but here we have an integer data type. They're different data types. Remember way back then you learned about data types, how we have string, int, bool, double, and things like that? Well, this random number is actually an int. So what we can do is get the string representation of the int. Essentially, we are converting, or the proper term in app development and programming is called casting. We're going to cast the int data to a piece of string data. So then it becomes the right type. And we do that by typing in string and then wrapping the int in a pair of parentheses right there. So now this would actually be proper. And this now is actually another error. So now you can see that the error, that little red underline, is on the variable player card. So remember, if I scroll all the way back up to the top, remember how I said that when these variables are declared under the struct like this is called a property. Well, we're going to learn more about structs and properties in the next module. But what we need to do here is essentially add a special keyword to this property or variable to define it as something that powers the user interface. Like it's a piece of data that the user interface depends on. And that totally makes sense, right? If you look down here, this image element right here depends on player card. Same thing with this one. This image element, which is, visually represented here, it depends on the state of this variable or property right here. So depending on the state of these two variables, it changes how the user interface looks. So what we have to do is add a special keyword in front of both of these called state, right? And the way we specify this is using the @ keyword, capital S, state, space. So you can see Xcode recognizes it as a special keyword, and this is called a property wrapper. So this is your property, and this is the property wrapper. And it essentially changes the behavior and attributes, kind of like a modifier. It modifies this property to just indicate that it is a special property, right? It is one that powers the visual state. So we're going to add the same keyword or property wrapper to the CPU card down here. And then if we scroll down back to the deal button, you can see that all the errors are gone. And we're going to randomize the CPU card as well. Card plus, and then we are going to go say int random 2 to 14. Right? And then we're going to have to, I'll show you this error because last time I don't think we took a look at it. So here, cannot convert value of int to expected type string. It's saying that this should be a string. So we're going to turn it into a string. All right, no errors. Perfect. So let's take a look at this. We'll run it and we'll try it out because we should be able to visually see these cards change. As we tap on this deal button, it's going to run this function. It's going to assign a random card number to player card and then CPU card as well. So you see that's really cool, right? It's actually working. Now, if you accidentally specified a number that doesn't exist, like these actually have to represent an image asset. So if you put 15 and you hit deal and it randomizes the 15, it either will show a blank. Let's randomize from 1 to 1 and you can see what I mean, because we don't actually have card 1 here. So it's going to be an error. It's not going to be valid. We have to stop the project and run it again. And yeah, there you go. It can't find that image because randomizing 1 to 1, you're only going to get card 1 and there is no image asset named card 1. So just a little warning for that. Okay, so let's change that. Command R to run it again. Now we get this.
Okay, now we need to add some conditional logic to the app. This means code that can decide if this condition is true, then do this. Otherwise, if that condition is true, do that. And in Swift, this is called an if statement. Let me show you how.
So here I have an empty playground to show you how simple it is to express conditional logic in Swift. And all you have to do is use the keyword if. Just like that. And next, you're going to put a space and then you're going to put the condition that you want to test. Now, with an if statement, it is if the condition is true, then execute this code. And if it's not true, then don't do anything. So why don't we say if A is greater than B, that's my condition. So if that is true, then execute the following code. And you put that code inside a pair of curly brackets like that. So I'm going to write a comment, some code here. Like it's whatever you want, as many lines of code as you want. You can even call a function here or do anything like that. So we are simply going to print, let's say, bang. Now, what is A and what is B in this condition? We haven't declared them. So let's declare two variables. So var A equals 4, var B equals 5. So actually, why don't we make B shorter or smaller? So this condition becomes true, right? A is 4, it's greater than B is 2, right? That is true. So this will get executed. It will go into this code block. Let's run the playground and see if that actually is true. Let's click this button to open up the console. And you can see that it gets printed out right here. Now, what if I changed B to 20? And let's stop the playground. Let's run it again. And you'll see that this time nothing gets displayed because it comes down here and it tests this condition. It finds out this condition is false, then it's not going to run this code. Now, the powerful thing with if statements is that you can specify multiple paths or multiple branches. So if you think about this condition and this block of code being one path that it could go down, you could also specify another. You could say else if, and again, you specify the condition here and then another block of code. So let's say if, if B is, let's use another variable. So let's say if B is greater than C, then do this. So we'll print shoot. We don't have a C yet. Let's put a C there. Let's put C is equal to 10. So in this case, what's going to happen? It's going to first execute this, right? And is it going to be true or false? A is 4, B is 20. This is false. Then if this is false, it's going to skip this and it's going to test this else, right? Else means like, okay, if that's not true, then what about this, right? Else, if this is true, B 20, C is 10, it is true. So it's going to then come in here. So it does this instead. Now, what if C was 30? Let's run it. Can you guess what happens? You can pause the video and take a guess if you want. Nothing happens. Why? Because it comes in here. This is false. Okay, well, let's test this one. This is also false. So it doesn't go into either path. Now, what happens if I did this? What if C is 10, right? So it's going to, this is false and this is true, right? It's going to come in here. But then I change A to 40, right? So this becomes true. Do you think it's going to type out bang and then type out shoot? Nope. It's only going to take the path that is true, the first path that is true. And it checks the conditions from top to bottom. So it tests this one. Oh, that is true. 40 is greater than 20. So it's going to come into this path and it's going to ignore everything else. It's just not going to even check the other paths. So that's why you have that, even though both of these conditions are true. So the thing is, you can specify more branches if you'd like. You can do else if as many different paths as you want. And then there is also a catch-all, or sort of like a last resort path if you want to do that. And that is just simply else. So if this is not true and this is not true, then it's just going to execute this, whatever's in here. So if I run this, it's going to come in here because this is true. So let's change A back to 4. So this is going to be false, right? 4 is not greater than 20. And then let's change C to 40. So again, this will be also false. 20 is not greater than 40. And so it's going to come down here and it's going to execute this. And this is sort of like a last resort. And you could have something like this. The else, if, and else, these two clauses are completely optional. You can only have one else catch all path, but you can have as many else if paths or branches that you'd like. So in this case, it would execute hello. Because this is false, then it just comes down here. So hopefully that makes a lot of sense, pretty simple to understand. And in terms of testing for equality, here's greater than, there's less than, and then you can do less than and equal to, or greater than and equal to. You can do not equals, that's exclamation mark equals. And if you want to test for equality, it's not equals, because remember, the equal symbol is for assigning something to something. So here we're assigning 4 to A, we're assigning 20 to B. So here we're not trying to assign B to A, we're just trying to test if they're equal. If you're trying to test if two things are equal, you use equals equals. Like that. And so if we make A equal to B, so that will be true, we'll see bang.
All right, now let's apply our newfound knowledge to the war card game. Let's do it.
So back in our war card game, in the deal function here, we want to update the scores. So we can use if statements. We want to say if the player score or card value is higher than the CPU card value, then we want to increase the player score. Else, if the CPU card or card value is greater than the player card value, then we want to update the CPU score. And if you scroll all the way back up here, you'll see that we have two properties, variables, keeping track of the player score and CPU score. So we're just going to increment this by 1, depending on whose card value is higher. So going back down here, we're going to use the if statement, if, and then we're going to compare player card value with CPU card value. And how do we get the card value? Because if you take a look at this, we're randomizing the number here. I've strategically chosen the numbers so that they represent the card image asset, but they also represent the card value. So down here, card 2 is smaller than any of these numbers, right? So ace, that's why I made it 14, because ace should be the biggest. So if someone randomizes an ace, that would be 14, and that would beat 13, which is king. So what we need to do is to be able to compare this random number with this random number. So we need a reference to it, right? But how do we get a reference to that number? Because I've specified it here and it's going to get joined together with this card. So I can't actually refer to it. So the strategy we're going to use is to, instead of randomizing it here, let's randomize a number from 2 to 14 and assign it to a variable. And that way we have a reference to it, right? It goes back to that first Swift coding lesson you did a couple lessons back about using variables to keep track of values. So here we are going to declare a new value. Let's call it player card value. And we are going to assign to it this. Right, so we're going to randomize that number from 2 to 14 and we're going to assign it into this variable. And then in here we can specify that variable right there, right? And turn it into a string because this is an integer, right? That's going to get assigned to this. And then we're going to do the same thing with this CPU. Var CPU card value is equal to CPU card value. And then we're going to now be able to write our if statement. So if player card value is greater than CPU card value, then we are going to add 1 to player score. And to do that, we can say player score, and that's the variable that we have way up at the top of this file. We can do this, we can say equals player score plus 1. But there's a short form way you can write this, which is this. Plus equals 1. And that is just going to increment whatever score it is with 1. Okay, so we're going to do it the shorthand way. And just like before, we have an error because remember, player score is a piece of data that the user interface is dependent on, right? It gets displayed in this text label right here. You can see right here, this text, and this text right here. So what we have to do is add that state property wrapper to it, just like we did with the player card and the CPU card. All right, now we're going to come back down and no error. So down here, would I add an else or an else if I want to now compare, right, if the CPU card value is greater than the player card value? Now I could use if, and I can say, you know, in that case, CPU score would plus equals 1. But there's a problem with this because this is comparing player card is greater than CPU card. What if player card value equals CPU card value? What if they rolled exactly the same value? In this logic, the CPU would win even if the values were tied up, right? So I would not use else here. I would use else if CPU card value is greater than player card value. And then you can say else, this is a tie, right? And then you can handle this how you want. So in this case, this would be like add 1 to CPU score. You see how handy adding these comments are? It really makes it a lot easier to understand your code, especially for someone who is new and learning how to code. Yeah. So for this tie scenario, you can add 1 to each score, you can minus 1 from each score, or you can do nothing. So I'm going to choose to do nothing, but you can do that differently. So let's see if this works. Let's run our project. Oh, what happened there? I rolled a card. Take a look. I made a mistake. This is a perfect learning opportunity. So, right here, player card is equal to card plus player card. But that doesn't make sense, right? It should be equal to player card value, right? Because this is the random number. So I don't know if you caught that earlier on when I was writing that, but if you did, kudos to you, props. But if you didn't, then you're in the same boat as me. I totally didn't see that either. So you can see it works now. Well, I'm going a little fast, but ace. So player gets that. Oh, it's a tie. See, there's a tie, so nothing happens. All right, looks like it's working. And there's actually more ties than I thought there would be. There was another one.
And there you have it. You've built your very first app. Now, before I tell you what you'll be building next, let's do a quick recap of how far you've come. You've learned how apps go from code to App Store. You've learned your way around Xcode. You've learned how to read and write Swift at a basic level. And you've learned how to build simple user interfaces. But more importantly, you've stopped doubting yourself about whether or not this is for you. Now, I want to introduce you to what comes after this war card game, the menu app. This series continues from where the war card game left off and prepares you for the next step in your iOS journey and beyond. Now, don't be fooled by this simple scrollable list. This is something that you could learn from tons of tutorials out there, but we're going to take it a step further. Not only will you learn the skills needed to build this app, but we're going to modify the code afterwards to mimic that of a more complex app. Now let me explain. Many tutorials teach you how to build a simple single screen app, and with good reason. It's a great starting point, and you need to learn to walk before you can sprint. The problem is that there's a conceptual leap from a single screen app with self-contained data to a multi-screen app that fetches data from a variety of external sources. And not only is the code more complicated, but you'll have to understand aspects of networking, concurrency, proper app architecture, and coding for reusability, just to name a few. So in the second half of this menu app video series, that's what we focus on, explaining these concepts in preparation for the next larger, more complex app. So that's all fine and good, but when is this menu app video series going to be released and where can you watch it? Well, I'm happy to announce that it is free to watch on the Code with Chris learning platform. The reason it's not currently on YouTube is because the menu app series is a step up from the war card game in terms of skill level. So I wanted to enhance the learning experience with practical exercises, quizzes, and human support. Now these things are all available for free through the Code with Chris learning platform. Now I want to be fully transparent. Aside from the quizzes, the challenges, and the human support that you're going to receive in our forum, you're also going to get a special offer to join CWC Plus, where you can get access to all of our available courses. You see, Code with Chris has grown into a business with a team of people behind the scenes making it all happen. And I thank you for your support over the years, and I hope you continue to find our iOS teaching valuable. Obviously, you're free to ignore the offer if you're not interested. Either way, you're still going to get access to the menu app video series, the exercises, the quizzes, and our team will support you in your learning, whether you're a paying customer or not. So to get access to the free menu app series, simply visit codewithchris.com. In the upper right corner, click on sign in, and then click on the register link right below the form and create a free account. Right away, you'll be redirected to the student dashboard where you'll find the menu app course card. Simply click Start Course to begin learning. Thanks, and I hope you enjoy this menu app video series which I've created. I'll see you in the next lesson.